including the type of meal like shake bar, shake
Shake and
shake
bar.
and bars, but because we don't really know what's the name of the type of diet, so we just say that there's it's not specified. But actually, we why we included because it focus on specific gene variants related to type 2 diabetes, and also and then I think it's the study is really connect with us. That's why we include it in our study.
Because your study is the objective not only the variance of genes to the obesity and the diabetes type 2. There's also the objective is what's that? What kind of dietary factor that can be useful for the that patients for obesity and
Okay,
types
to
2.
respond that, actually, we can see this is the standard diet, like a Mediterranean diet and low protein, high protein, the standards. But some of the studies only selected a specific nutrients, like carbohydrates or even just protein, and we have no standardized name for that kind of diet. That's why we put here as not specified, but the studies definitely have dietary patterns, dietary information in that studies.
Yeah, next question. I would like to ask, how do you avoid selection bias in selecting the article? Because from what I can see here, that when I look at the genes analyzed, there are several of them which were twice, and like the FTO, you have this one, two, three, four, well, more than once, more than twice. But then the other genes, these are only ones that you include in paper, and also there's I can see some bias over here because even in the introduction, FTO is really there. You mentioned it, right?
Yeah. Yes, if you now we already mentioned that this is a scoping review, so we don't have really need to measure the risk of bias. However, we emphasize and maintain the quality in the selections process, and we already posted the protocol, the complete protocol in here, and you can see the complete protocol there. And we did independently assessments to select the studies.
Thank you very much for everyone. Now we will have a 1 minute break before we continue to the other team's presentations. Oh, the final one?
The one with 3 minutes thingy.
2 minutes.
Yeah. Sorry, the name is something else. There's 3 minutes over there.
Oh, okay, okay.
Sorry, sorry. Excuse me, excuse me. Cycle two. Bagus lah, 42. Yeah, the one with 3 minutes. Yeah, there you go. Sorry. Yup. Check.
Okay, let's set the timer for 3 minutes first. Okay. Yeah. Ah, sebentar. Can we pause?
Check.
Start your presentation now.
Okay, good morning, ladies and gentlemen. It's nice to meet you, Mr. Ufan and Mrs. Mr. Ufan and Mr. Imam. So, my name is Yaakob Slaudon Sinaga, and I'm here with my partner, Diatni Fauzia. We're here to present our paper entitled Effectiveness of Rotavirus Vaccination on the Incidence of Diarrhea in Children in Panghegar Public Health Center by 2024. So, as we all know, that rotavirus significantly contributes to child mortality, causing 39% of global diarrhea-related deaths in children under 5. And in Indonesia, it leads to 45% of of infant hospitalization for acute watery diarrhea. And actually, the government has started to do something about it, in which it launched a vaccination program launched on August 23. But yet, coverage goals remains unmet. And then it highlights the need for further analysis of factors affecting its success. So, what we did is that we have a case control study design in which we divided our population into two. The first one is children with diarrhea, or the case group, and those without diarrhea in control group. So we got 37 children from the Panghegar Public Health Center, but then we had to exclude 8 because 3 of them were not at home despite multiple home visit, and then 5 children moved to another location. So for the control group, we have 1:2 ratio, 1:2 ratio with total sampling. Next, we selected one group for one respondent, and we spaced them 10 houses apart to select the control group. These are the results of our studies. So the result shows that there were disparities in vaccination rates across the doses, with higher uptake in the control groups for the first, second, and third doses. And furthermore, the visualization underscores the need for improved vaccination strategies to address gaps in vaccination. And more research shows that rotavirus vaccination can prevent the incidence of diarrhea in children by 1.86 times after adjustment. And then it means that any improvement in vaccination status will prevent the occurrence of diarrhea. And then the result of certification analysis showed that there was a difference in the odds ratio in the mother's education strata, mother's age, mother's occupation, and the type of caregiver at home. The conclusion of our study shows that the study found that rotavirus vaccination coverage was significantly lower in children with diarrhea or case group compared to those without or control group. And then multivariate analysis showed that rotavirus vaccination reduced the risk of diarrhea by 1.86 times after adjusting for the age of the children. This highlights the needs for targeted public health strategies to increase rotavirus vaccination coverage and ensure timely administration, especially among vulnerable groups. Thank you so much for your time.
Okay, thank you so much for the presentations. Let's set the timer for 6 minutes.
Thank you for your great presentation and also interesting result. But I'm just wondering for some points of your research. First, it's related to OR value, odds ratio. As far as I know, the risk factor categorized is as a risk factor if it's more than 1, and if it's less than 1, it's a protective factor. And here, the rotavirus should be considered as the protective one, right? Not a risk factor. But you found that.
So in this result, the rotavirus vaccination reduced the risk of the factor 1.86. But this is the prevent to the area itself in the Panghegar Health Center.
However, because it's 1.86 means it's a 1.86 have a more risk to get a diarrhea. It's not like if it's less than 1, then it should be protective. If it's like your claim, but it's kind of like contradictive. What as far as I know about the risk factor meaning. Thank you.
The rotavirus reduce. This is just make a sentence that the reduced risk means that can prevent. There is for the what's that or not from the not adjustable. There is 3.2 to what's that reduce the risk. But this isn't to prevent, but reduce the risk if we have three times for get the diarrhea. This is reduced 3 means apa what's that 3 means 1.86 times.
Yeah, I don't want to spend much time about interpreting your research, but I suggested that you see again how to interpret odd ratio, what's the meaning, and I want to move forward to asking about the methods of your research. That you're selecting cases, 10 houses from cases, right? How you ensure that there is similar patterns of exposures. Yeah.
Because in Panghagar there is child age that group that's they have a habitual the same habitual actions, and then they have same activities in many times in a days, so that we have that the what's that include what's that inclusion, that's inclusion criteria uh, to make a matching a group from the cases and the control group. There is some this the same what's that same habitual action.
Yeah, I don't think that selecting 10 houses reduce the possibility of confounding factors, because between 1 to next 10 houses, there's a lot of differentiation between like health care access, diets, exposure to environments, and many things, and even the gender and age. That's also could be confounding factors affecting your results. So I don't think that's good.
For choosing a compounding factor and many else, we have design study before, where we have paper before. We have a confounding factor not for ours that we choose factor characteristic individual, but we have based on the paper from the research before itself. That's not because of our what's that willing. There is a paper for before.
Yeah, but I didn't get that explanation before, so you should provide us the background. And I move next to how you collect vaccination record directly to the house, or door to door, or from Puskesmas, or where?
Yeah, we got it from the Puskesmas. Actually, one of the inclusion criteria is they should have a KMS book or kartu menuju sehat
Yes,
habilitas
that's the problem. If you get from the Puskesmas, then how you ensure that the data from Puskesmas is next 10 houses from the cases?
Okay.
How I can't imagine how difficult to select your control based on the data from Puskesmas if you're not doing door to door.
Yeah, actually
Yeah.
we're doing door to door. So we get the data first, we get their address, and then for the control group, we look for we space them 10 towns apart, in which we look, of course, we look for families with infants, okay, which is under 5 years old, because there were many times when we doing our visits, there were multiple times in which they don't have children in their household.
Okay, but yeah, I still bothered with the way you selecting your control. But let's move another things related to that. How well? Maybe I change my question. How well your methods achieving the goal of creating a good control or comparables? That's my point of questions. Yeah.
Yes. I think that we can explain about how about the case group from the Panghagar Health Center, and then the control group from the what's that, the society near the case group itself. So we can what's that? We can examine or we can find the control group if there is vaccination or no vaccination. We just control group there is based on the cases the diarrhea and the Panghagar Health Center. If there is no cases, the what's the control group no cases in the Panghagar.
We have the scores for this match. It's a very tight match. And the winner for this match or tournament is Team 79. Let's give them a round of applause. So before we continue to the okay. Before we continue to the next sessions, let's hear from the judges first. And okay, you have 3 minutes.
Yeah, thank you very much for the team 42 and 79. So it was a good debate to me. Yeah, some of my input will be for 79 team. I I'm very happy with your introduction. I mean, you highlight why this study is needed, but you have to watch out your time management. I think you spent so much in the introduction, and then you were in rush for the methods and results and so on. Um, that first. The second one is most of your questions to the most of the question coming from 42 team is about the selections of the study. Yeah, because your study.
Okay, hold on. I'm sorry. I'm sorry. So I want to make clear. So this is the competition between the teams. In the qualification tournament for this, we had a judges session for feedback, but this is a double elimination round. So there's no coaching on content or anything from the judges or recommendation to anyone in this. Yeah. Okay. I just want to make that clear.
Okay, bye.
Other comments
Our
are
other
certainly,
presentation is
certainly okay
Yeah.
with respect to, keeping on time or general things
Yeah.
like that. That would be okay, but not like before where we were actually providing additional. Okay, just want to make that clear. Okay, sorry.
Okay, so let's give them a round of applause. Thank you so much for the.
A little bit for us.
Yeah, and for you. We give it for team 42 also.
For the input.
Oh, for the input. Okay, we give it
A little bit.
Oh,
For our team, because you give input to them a little bit.
I can give, I can give. I think the presentation actually is slightly more structured by Team 42, but the issue is that from the match point of view itself, Team 79 is just better at transitioning to a better theme, so that the discussion can cover more parts of the research rather than how Team 42 structures their questions. Thank you.
Okay, now I will like to invite team 61 and team 88 to take the seat. Which group are you? 88. So, okay. Okay, for team 61 and team 88, now we gonna start the tournament. Wait a minute. So before we start, I'm gonna re-explain about the house rules. So the defender teams will explain their studies in 3 minutes, and the attacker teams will give their questions within 6-minute question and answer. And during the 6-minute question and answer, the defender team have 1 minute to answer about the critiques that are given by the attacker team, and the attacker team have 30 seconds to attack or give comment and critiques about the studies. So before we start, we're gonna toss the coin. So you can choose which side. The head one, and you will be the So you will be the attacker first, and you can defend your presentations first. Team 61, okay. Okay, you can try first. Okay, let's make the timer for 3 minutes. Anything.
Okay.
You're
If it's
comfortable.
okay, I'm gonna sit. Okay.
Wait a minute. Okay, you can start your presentation now.
Okay, good morning, ladies and gentlemen. So today we're going to start with the title of the Housing Distance, Salt Intake, and Cardiovascular Risk in Rural Aceh Tamiang. Insights from the WHO non-laboratory assessments. So as an introduction, as you can see that the major cities have access to specialized healthcare, but unfortunately in rural regions, they face significant physical barrier addressing their cardiovascular rates. Specifically that we're trying to highlight is the Aceh Tamiang portion of Nangor Aceh Darussalam. So we're going to use the WHO non-laboratory graph from here. And these are the cross-sectional, and it includes 40 years old and who consented. So the methods that we're also estimating is the high and low risk. The high risk estimated of 10-year cardiovascular risk, and then within the systolic blood pressure of higher than 140. So the salt consumption is instant food consumption recall with low, high, and low and high, and then activity level is light, moderate, and vigorous, and then house distance is very close, close, and moderate, and far. So these are the conceptual framework for this. We're going to use the binary regression, and then the Hosmer-Lemaitre test to see the model fit. Now, for the results, as you can see, it is majority female, and within the 50 to 54 age range, and then with the smoking history, most of them they have no smoking history at all. With the systolic blood pressure is still within the normal range, which is the 120 to 139. And then the BMI classification is unfortunately rather high with the 25 to 29. So as a result, if we classify from the snaky diagram here from the WHO to the high and low risk, most of the one in the high risk is within the 10 to 20%. As you can see, we have the added of the above 140 for systolic blood pressure. So when we do the additional characteristic regression, you can see that the one that is significant is the salt consumption and also the housing distance. Now, from a multivariate graph like this, you can see like the salt moderately it is higher from housing distance, and then this we can see that the systolic blood pressure is predominantly higher within the high salt consumption. And also from here, you can see that the distances, it doesn't really, dispersed proportionally, but unfortunately, if you see the BMI, it's mostly closer, that is tightly packed within the close range and the higher BMI. So the conclusion is housing distance and salt, dietary salt intake should be considered to optimize therapeutic strategies as it is correlates to the risk factors from these populations. Thank you.
Okay, now we are going to have a 6-minute question and answer. Can you set the timer? Okay, and you can start now.
Okay, thank you for the nice presentation. First of all, I want to make sure, did you ask whether participant having CFD or not, or labeling based on the prediction of
So actually we did ask, but sometimes it is from their own recall, and cardiovascular diseases that they have is really underdiagnosed. Sometimes they would say that I do have it, and sometimes they would say that they don't. So there's a bias of whether or not they can take and have the diagnosis to the hospitals or anything. It's basically from themselves as well. So whether or not they got diagnosed and within their own high systolic blood pressure, it's not very corresponding to it. So we can say that they did ask. Did we ask? Yes. But did they provide without any bias? I don't think so, because it's not really a generalized diagnosis for all of those sample sizes in those puskesmas that we asked. So we decided to omit that because that could become something that is a bias to them, whether or not they got the diagnosis or not. So.
So there's possibility that the participant, for example, have low salt intake, good physical activities because they have been diagnosed with CFD. So I'm afraid that your study is high of bias. But in the conclusion, you confidently say that those factors are need to be considered to be optimizing therapeutic strategies. Do you still how confident you are to say this?
Okay, so I'm still very confident because like if we're considering only the cardiovascular disease, especially when they're sedentary and they have a low salt intake or they have been to the hospital and they got their diagnosis and everything, we still believe that it is significant simply because within the systolic blood pressure, which is one of the predictors to all cardiovascular diseases, acute coronary syndromes and things like such, they already have like a high salt intake itself and it corresponds to their systolic blood pressure. So I don't think that whether or not the bias of them having a diagnosis, acting upon those diagnoses, have anything significant in terms of their own risk factors and how they would apply to it, and whether or not it would affect the conclusion of the study. So yeah, thank you.
All right. So move to the how you define the factor of salt intake. The salt intake is measured using instant food consumption, right? But the instant food consumption may comprise of like also other than salt like glucose and etc. So I think that the salt intake should be defined to be like a sodium intake, right? So I think that this subjective to bias.
Again, I feel like that is fair, considering that it is to sodium. It is specific to sodium, considering we're using salt. But unfortunately, we are working with rural people. We're working with puskesmas. We're working on those recall. So if we're trying to say like how much of your sodium intake, they cannot specifically say like, oh, we're gonna use 2 grams. We're gonna use 2 grams for a diet for one whole day. So it is easier for them to say, how many times have you eaten Indomie in this 1 week? How many times have you eaten outside within 1 week? Because like again, if we're asking about them, oh, how much of your sodium intake, they could easily say like the recall is like, oh no, it's just a tiny bit. I only added a little bit on my food. So it's very subjective. It's very highly to bias and whether or not they want to show that they're, oh, we're good people. You know, we're good. We don't apply with a lot of salt because considering that they're above 40 years old, so there are higher chances that they are within the high range of cardiovascular risk. They might feel like they're gonna be judged based on those sodium. Thank you.
Yeah, but I think still for the older people, you can just ask how many times you eat salty food like that. And then about speaking about the age, the study only include age above 40, right, from a single rural district in Aceh. But how about other people population like younger? So I think this study cannot be generalized in Aceh.
Actually, the reason why we added in 40 simply because the WHO non-laboratory risk assessments only dictates it's from 40 to above. So this is based off of the WHO. Should we do it from 40 years old and younger? Maybe, but it is still not specific to what it guides upon. So from the risk factors like this from the WHO, it is specifically said that the risk factors that they have done in their own cohorts is specific to 40 years old and above. So we're going to use that only because like if we added like younger generations, for example, like 35, 27, it's going to be not specific to the WHO risk factor heat map, as you can see here. It's not really applicable, if you may.
All right, then why don't you consider other standard other than WHO? Because if you ignore the confounders like the younger age or more like poverty, socioeconomic and pre-existing illness, your model then may pick up false association. So I'm afraid this can weaken your claim.
So the reason why is we did actually dive into which model should we use. Like, should we use WHO? Should we use from American Heart Association? Should we use the WHO laboratory? But unfortunately, within the selection of those model itself, it is not applicable if you want to use it in rural. For example, the WHO laboratory, they use the LDL measurements. The LDL measurements is not really, sometimes, okay, puskesmas is not enough.
Okay, thank you for everyone. Now we're gonna have a 1-minute break before we continue the tournament. Okay, now we are going to continue with Team 88 presentations. You can try the clicker first. Okay. Okay, we can set the timer for 2 minutes. Okay. And you can start your presentations now.
All right, good morning everyone. My name is Indira and my friend Rizal. Today we want to share about our research about optimization of peptide-based drug design targeting reverse transcriptase HIV using QSAR integrated with machine learning and quantum mechanics. So despite the advancement of HIV treatment, there is research that show more than 30% of patients have missed ARV to avoid the side effect. This is worrying because it may lead to drug resistance. Therefore, we need a new and better therapies. Peptide-based drugs could provide solution to this because they are more specific, lower side effect, and less likely to develop resistance. In fact, reverse transcriptase is the most effective drug target for HIV because it doesn't exist in human cells, so targeting HIV reverse transcriptase can increase the specificity of drug. Therefore, in this study, we aim to design peptide-based drugs targeting HIV reverse transcriptase with the optimization using QSAR, machine learning, and quantum mechanics. So this is our method. First of all, we built the machine learning model based on the database of compounds from DUT. And it comprises of 2D, 3D descriptor, chemical fingerprint, and interaction fingerprint. It was used to train the machine learning model and then we evaluate the model. We choose the best machine learning model to predict and screen more than 2,000 tripeptides library. We choose the top 5 peptides based on MMG-BSR scoring, and then we further do verification with the DFT assessment and molecular dynamic to choose the most potential peptide. And then this is the result. So from several machine learning model, we choose random forest because it has highest accuracy, more than 90%. And then the best model was used to screen the peptides. And from the MMG-BSR scoring, it shows that the NHY peptide exhibit the most negative binding energy, even compared to the drug nevirapine. So it indicates that it has strongest interaction with the reverse transcriptase of HIV. And it was supported with the docking analysis that show NHY share similar residue of interaction with nevirapine, so it has similar way of interaction. And then it was also supported with the DFT assessment that show that the NHY peptide has energy gap between efavirenz and nevirapine, so it indicates that it has higher reactivity and more stable. So the conclusion of our study highlights that NHY as a promising peptide inhibitor of HIV reverse transcriptase, but however, these findings are limited to in silico prediction and require experimental validation to confirm the NHY efficacy and safety in a biological context. I think that's all from us. Thank you.
Okay, thank you very much for the presentations. Now we are going to move the 6 minutes question and answer. Please set the timer first.
Test.
And you can start now.
Okay, thank you for such a great presentation. So I would like a question. First of all, what is the aim of your study?
Okay, first thing first is the aiming of the study is we wanna check about the non pharmacophores groups that have the impact into the increasing the binding energy in the RT for the HIV, and then we wanna know about the how the minimum requirement of the peptides or maybe the R group and the peptide that can influence in the binding affinity in the HIV reverse transcriptase.
So for simplification, we want to screen from more than 2003 peptides to choose the most potential peptide for the inhibitor of HIV reverse transcriptase.
So basically, what your answer is, your aim is to provide a new treatment for HIV patient, but for whom HIV patient, which type? I mean, there are so many different types of HIV patient.
For this initial phase, we want to focus on the HIV-1 first, and specifically to the receptor of reverse transcriptase HIV.
And for what type? What type is HIV for the new patient who has been diagnosed with HIV or HIV with stage 4 or HIV stage 1, stage 2, stage 3? That type.
In previous study that I'm read before that the peptide-based drug is better to use for the earlier patients in the HIV conditions, and also in the next steps, in step 1 and step 2.
So actually, we compare this peptide that we have choose with the efavirenz and nevirapine that was used for all layers of HIV. So yeah.
So I guess in the first slides, it is said that you want to evade the side effects that might cause the patients don't want to have side effects, and therefore it leads to drug resistance, the one that you said. So within the current guidelines, the HIV consists of 2 NRTIs and then 1 NNRT. The NNRTIs, I think, is the efavirenz and the nevirapine. So why do you go for the NNRT, which is the efavirenz and nevirapine, not the NRTIs itself?
Yeah, because we want to target the reverse transcriptase because it is the most effective drug target for HIV, because in human cell we don't have reverse transcriptase enzyme, so it can increase the specificity of drug. And then based on the research also, it showed that there are like more than 800 people that has trouble with the side effect of current ARV. So that's why we want to provide a peptide-based drug that is more specific, and because it's more specific, it can lower the side effect of that.
Okay, so considering with the peptide as well, they have a very different bioavailability, their membrane permeability, and also their enzymatic degradation. They're very volatile and very, it's not as concrete as the conventional drug itself. So how would you feel? How would you react to the bioavailability? Will it have the same longevity of treatments, and will it have this less side effects? Thank you.
All right, so I want to remind again that this is just the foundational computational study and the initial phase. But in this study, we have studied that we select the polar peptide because the receptor pocket and the active site of the reverse transcriptase is also polar, so it can increase the bioavailability. And also, from the molecular weight of the peptide is lower than 500 Dalton. If it is lower than 500 Dalton, it may increase the permeability based on this journal. So I think.
Okay, thank you. And I also want to note that in your abstract, you did not explain what is the NHY peptide. It's so confusing to read first. What is the NH7? So it's better to if you want to explain it first and then you shorten it.
All right, thank you for the suggestion because we have limited limited space in the poster, so we may miss it. But I want to explain about the NHY. NHY is a tripeptide. So NHY is amino acids. So the three of it is defined as the tripeptide. So it's like a protein, small protein.
So you also stated you have 2,197 peptides. How do you have that so many peptides, and why did you choose to illustrate with random forest in your abstract? Thank you.
All right, so I want to answer the second question first. Why I choose random forest? So actually, we train from SVM, random forest, and other deep learning, and we choose random forest because it
Okay,
achieves the
time's up.
highest accuracy.
Thank you very much. Let's give them a round of applause. And for this round, we already have the winner, and the winner is Team 88. Congratulations for Team 88. And also thank you for Team 61. You may leave the seat now. Thank you.
Jurusan apa? Tahun? Enggak kena.
Okay, for the next presenter, Team 7 is there here. Team 7 will be competing against, let me see. Okay, so Team 7 will compete against Team 6, if I'm not mistaken. Okay, wait a minute.
Is the question same as before, like 30 seconds? 30 seconds to us? Yes, 30 seconds to us. 1 minute to...
Do you guys want to check the presentation first? For Team... Oh, no, okay. So, okay, this is Team 7 and this is Team 6, right? Okay, so before we start... Okay?
Slide number 3. Number 3.
Is it the correct one?
No, I
No?
already updated.
Oh, okay, you already updated?
Yes,
Okay.
I uploaded in the same link, not this one. Dojo Second Teams, not Teams file. Not this, not in this folder.
Okay, okay, we're gonna check
Cycle one.
first.
Team file. Then public maybe. Okay, let me check first if the team. Material. No. Okay, I will ask the committee first. Okay. Right. No. Kasih linknya aja kan ya? Boleh dikasih linknya aja. Cepat. Makin lama makin mulus. Udah salah. Banyak banget satu kali. Enggak, ini mah cuma dikit. itu.
Yang loser.
Bracket yang bawah. Bracket loser. Ntar tanding lagi kalau tetap kalah.
Tuh, aku udah upload loh yang baru. Oh, kan yang ini.
Itu kapan diubah dua-duanya?
Bukan yang ini. Namanya bukan ini kemarin. Boleh buka laptop nggak? Aku kirimin sekarang.
Nama pengen pipis lagi. Kenapa sih harus ngomongin boker di meja ini?
Tadi berarti kisah ya lawan.
Kisah.
Lawan apa? Siapa ini?
Yang mana?
Yang Cina Islam itu.
Cina Islam.
Kan tadi itu.
Dalton. Emang Cina Islam?
Gak dia bilang.
Emang si Dava lawan siapa?
Ntar lawannya tadi.
Lawan yang
kisah-kisah.
yang menang tadi.
Doking.
Yang doking.
Iya.
Iya tadi dia stres.
Iya udah.
Kok aku takut ya? Jujur riset kalian tuh nggak ngerti kita. Riset kalian tuh biomolekuler apa? Bioinformatik gitu. Bioinformatik ya?
Tapi kakak jurusannya apa?
Biomedik. Ya, paling nanti ya.
Biomedik gimana?
BUE.
S2.
S1 UPI biologi.
Ya. Aku dari UGM. Dia dari UI. UGM biologi. Aku S1-nya kedokteran hewan.
Emang ada S2 kedokteran hewan?
Ada.
Oh ada.
Vet Med Science.
Eli, untuk punya Eli.
Sama nggak ada perubahan sih PPT kita. Oh berarti bukan dulu. Aku nggak tahu nggak bisa di.
Kok lama ya, makin lama di sini.
Ya, udah benar. Udah.
Okay. Okay, so before we start, I'm gonna re-explain about the rules. So each team will have, the defender team will have 3 minutes to present their studies, and the attacker teams will have 6-minute question and answer, where the attacker can ask for questions in 30 seconds, and the defender will answer about the critics in 1 minute. And before we start, we're gonna decide which teams go first. Which one do you like? Okay, numbers, and you're gonna be the head. And your team gonna attack first, and you're gonna present first. Yeah.
Okay.
Okay, wait a minute. Okay, and you can start your presentations now.
All right. I will presented my research about effectiveness of DMBA induction and the EMBA combined with hormone in mice as a breast cancer model. This is a systematic review. So The MBA only work as reactive epoxide metabolites, binds to cytochrome 450, and it can disrupt the P53 and RAS oncogene. It leads to DNA adducts, leading to mutation, especially in memory epithelial cells. If the MBA combined with hormone, the hormone itself acts as enhancer and promoters of the DMBA itself. So the DMBA will leading to mutation and also work twice faster. So it can promotes memory epithelial differentiation, and then hyperplasia, dysplasia, and also leads to carcinoma. This systematic review aims to analyze and synthesize scientific evidence on the use of DMBA and hormonal combination in mice as breast cancer model. This is the method. So we identified through a database like PubMed and Google Solars, and we got 123 and remove 48, screen the 75 articles, and then we proceed to Prisma, and then we assess the articles, and then we proceed again using Arrive. So we got 4 articles. First, the first study, the MBA alone, without hormone, the incidence is 100%, and the first tumor appearance in 29 days. But the histopathology features is not varied, and also the second, third, and the fourth studies using the same strain and also combined with hormone, but the incidence is lower than the MBA alone. And also the first tumor takes longer than the MBA alone, but the histopathology features more complex and heterogeneous. So the combination with hormone itself exhibit greater aggressiveness and histopathological heterogeneity, so it make it more relevant for studying hormone-related breast cancer and testing hormone-targeted therapies. Thank you.
Now we're gonna set the timer first for 6 minutes.
Yes. Okay, I wanna ask.
Okay, you can start now.
Okay, is using 4 articles can be called as a systematic review based on your opinion?
Sorry, can you make it more clear?
Okay, is using only 4 articles can be called as a systematic review based on your opinion?
Yes.
Why?
Because in systematic review, you don't need a lot of articles. As long as you pass the Prisma check and Arrive check, it's okay.
Okay, and then you use Prisma, and how do you use the Prisma? Because after using the Prisma, it's too much that you exclude the in the methodology.
Okay.
Too much article that you exclude.
Okay, because the DMB their study not only use DMBA or hormone, but also use a cell transfer from stem cells. So I excluded.
Okay, how are you confident about using this just for article that can represent that, oh, this DMB can effective for developing breast cancer model? Because just using for article just like my task course, my task lecture, just using for.
Yes, I'm pretty confident about this systematic review, because as long as they use because they follow my inclusion criteria and exclusion criteria, and also they pass the Prisma guidelines and Arrive guidelines. As long as they can pass these 2 guidelines, even just the 4 articles, it will reliable for me.
Okay, thank you. So if you're saying you're confident, so next slide, why from these 4 articles there's like the variation of the strain then?
The strain itself, it doesn't affect the results. What affect the results is the age of the mice, not the strain.
Okay, so if that you use the female Swiss albino as the control, but there's no knockdown in that, so that means like the progesterone and estrogen still can affect the result. How can you convince that it's not affecting the result?
Well, that's the point of this study, because if you use knockdown mice, those particular gene itself, we delete it, right? That's the use of this DMBA. The purpose of the use of DMBA is to know how it works in normal cells.
Okay, how to convince me about there are variabilization of the natural estrogen and progesterone and C5, the strand C57BL6, because they also have progesterone. There will have variabilization to affect the outcome.
Okay, you mean the natural estrogen and progesterone in the body of the mice?
This is not knockdown yet.
No, this is not
There will be variabilization that affect from the natural of progesterone estrogen, and that will be bias from the variabilization.
No, because I tried to find the study that mimic breast cancer in human, because in human we know a lot of use contraception using hormone like estrogen or progesterone. That's why this induction external hormone is needed.
Okay, so if you're saying you compare it with the human, why don't you mention it here? Like, why you not include the summary of the breast cancer using the DMBA in the human?
Like, there are no comparative study to breast cancer in human, because we want to make this model
to the human. Yeah.
Same with human, right?
Yes, that's why. Yeah. This is the aim, to analyze and synthesize scientific evidence on the use of the MBA and hormonal combination in mice as breast cancer model. Breast cancer model itself is mimicking human.
Yes, with breast cancer model, the outcome is how to these models can same physiology histopathology with human, right? So why is in your literature review, it doesn't have to be comparative with breast cancer in human?
Okay. That's the use of this histopathological feature. This is mimicking human breast cancer.
Okay, where there are no about image of histopathology, because there are like invasive ductal carcinoma, because the histopathology in cancer in human is too complex. So we should why you not display the histopathology of these four articles?
The point is, we want to know about the histopathological feature, the incidence, and the first tumor.
Sorry, what?
That's the point. The whole point of this systematic review is we would like to know about the histopathological feature, the incidence, and the first tumor based on these 4 studies.
Okay, we can return to the MBA. So I think the MBA is too general to attack DNA. So how effective is the MBA can develop breast cancer? So they will get like prostate cancer or other cancer. But
yes.
How effective is the MBA?
All right. Maybe it's not. I do not show it in my presentation, but the DMBA itself is commonly used in breast cancer research. Not only breast cancer research, but also gastric cancer and prostate cancer.
So
but
it's not accurate.
I don't say it's not accurate, but it's mainly used.
Thank you, everyone. Let's have a 1-minute break. After that, we're gonna continue with the other presentation.
Oh, ini kayak nyala nggak nyala gitu ya? Tadi, tapi sekarang udah nyala.
Sedikit sensitif sih.
Oh, pakai ini dulu ya, oke ya. Nanti habis itu baru tukar.
Cek.
Kurang poinnya.
Tadi 17 kok jadi 16?
Kok jadi 14?
Lah.
Okay. So there's a rule. Both of the
Participant must
yeah. actively participate in this presentations. If the judges think that one of the
But before 17, right?
Yeah, before
So
7.
I.
Yeah, it's okay, it's okay. Nanti ini kurangin. Oh ya, coba dulu ya, bentar. Do I need to stand up? Okay. Okay, good morning everyone. Now my team will present our research is about lasso logistic regression and artificial neural network for prostate adenocarcinoma metastatic prediction and biomarker discovery based on the gene expression profile. So move on to the introduction. Prostate adenocarcinoma or prostate cancer itself leads the fourth most prevalent cancer among men in Indonesia. And this type of cancer frequently advances to metastasis. As we know, the detection of metastasis only relies on histopathology and also CT scans, which are takes time and also costly. So the research objective is to first develop a machine learning model for predicting prostate cancer metastasis using the different gene expression data. And the second is to identify the key biomarkers linked to the prostate cancer metastasis. For the method, we gather the data, which is RNA-seq from the TCGA, and then we do the cleaning data and also imputation. After that, we do the normalization. After we gather the significant genes, we will start the feature selection 1, and then to the feature selection 2, and then we do the machine learning, and then to validate, we do the biomarker analysis. So the results from feature selection 1, which is DAG, we can see that several genes are significantly downregulated in the left side and also upregulated in the right side in metastatic prostate cancer. And then from the data distribution PCA, we can see the PCA plot shows distinct gene expression patterns between the metastatic, which is the red one, and also the non-metastatic, which is the yellow one prostate cancer sample. And the clear separation of data points itself indicates significant difference in their gene expression profile. And then go to the feature selection 2, we train the data with the lasso logistic and also random forest. But we choose lasso logistic because it shows the best performance up to 100%. And then we identify 7 key genes, and we select only 3 of them as the biomarker, which is MYH11, PRMT1, and TANT4A. To validate our data, we do cross-validation and also external validation. In the cross-validation, the XVM perform well, but in the external validation, the ANN perform the best, so we choose the ANN. And we do the biomarker pathway analysis, which is MYH11 is downregulated, leading to the cytoskeleton disorganization, PRMT1 upregulated and doing the EMT induction, and also TANT4A is upregulated and regulates mRNA stability, so it makes the cancer cell becoming hard to kill. Okay, so for the conclusion, lasso logistic regression outperform in the random forest in feature selection, and ANN achieve high classification performance during the external validation using only 3 biomarkers. And these 3 biomarkers are associated with metastatic induction through the cytoskeleton disorganization, EMT promotion, and mRNA stabilization. The limitation itself is this study only relies on RNA-seq data from Indonesia and requires more external validation. Thank you.
Thank you for the presentations. Now we're gonna set the timer for
Check.
Okay, I want to ask about the method that you use. You use the lasso logistic regression to identify the potential biomarker, right? So, and you claim that the logistic regression is showing the best performance 100%. Why you claim that the lasso logistic regression is 100%
Okay.
the best performance for this?
Actually, we have compare my lasso logistic regression with random forest. It's actually have deviates. It's 999 and 100. Then it has best performance rather than random forest. And in any articles, lasso logistic regression and random forest is commonly used for biomarker extraction.
So there is the standard for comparing to these two methods, right? And for the next question is about, you said that there is in the result, you said that AKT gene, the regulated promotes the bone metastasis. How can you conclude that? Because as I know, the AKT gene has many pathways that can influence other organs. Yeah,
Oh,
the
AKT
results.
genes.
Yeah, the genes. You said that the AKT gene promotes the bone metastasis. How can you?
Okay, AKT genes is upregulated in this gene. So there are also articles that say that AKT genes will express the cytoskeleton and so many cytoskeleton, so many actin genes that the expression will be get dysregulated of the AKT. So it will be detached from the basal if there are dysregulation of AKT.
All right. And then how did you know that AKT upregulation lead to bone metastasis instead of to other organs?
Sorry.
How did you know that AKT lead to the bone metastasis instead to the other organs?
Okay, so
Your data.
according to my data, AKT, like I said before, AKT is lead to the too much AKT and too low AKT will lead to dysregulation of the homeostasis or AKT, and it will be mempengaruhi, influence the cytoskeleton organization. If the cytoskeleton organization will be dysregulated, it will be have like cell detachment. It will be promote metastasis.
Yes, I know. But how did you know that it will go to the bone instead to other organs?
Because prostate cancer is usually can like prostate or maybe in muscles. So it's commonly in journal. It's common metastasis.
I mean, how the mechanism?
Mechanism is from a prostate, metastasis. So the cells will be distributed in the vein and come to the bone.
Okay, all right. And then why did you choose the three kind of biomarker instead of the other biomarkers? Like, as far as I know, a lot of growth factor that can be used as biomarker in metastasis.
Okay, the difference of difference model will extract difference biomarker. In my models that last lagi segregation, it has three high feature importance that have MHH1, PRMT1, and TNT4. They have feature importance that have high score, and we fed these three biomarkers to our model, and it has good performance. So why not? Why not?
So according to these three biomarkers, can it be applied in clinical setting, or we need further research to prove that?
Yeah, of course we need further research. For example, like the real clinical studies from the patients. Yeah, we need further clinical studies to.
Yes, this is in silico studies. We use public database, but in clinical studies, we can use these biomarkers like qPCR and fed this result of qPCR from this biomarker to our model that will be resulting that this patient have metastasis or not.
All right, and then why don't you use Indonesian patient sample and do the RNA sequencing instead using TCGA and then run the analysis based on the Indonesian samples?
Yeah, because we don't have any of the Indonesian sample, but because of that, we use the TCGA, which is from the American and also the Europe, which is like normal for in other world, and also it can be used also for Indonesian patient. Once we have like the small data, through the small data, we can like pre-train the Indonesian patients data with this data, so like it doesn't matter.
So we can retrain our models
Yeah.
if we have smaller data
yeah.
of our Indonesian.
But in the fact, we don't have any.
And then how high is the risk of predictive error of this model is applied to Indonesian patient samples?
How is the error? How is error is dependence of so we should test our models to data, the Indonesian data, so we can say what is the error. But this TCGA data, the American and Europe data is commonly used. It's commonly used in journal article for worldwide.
And then if proven accurate, could this biomarker be translated into molecular rapid test for clinical use?
Sorry? Oh, molecular rapid test. Yes, this model and this biomarker can be used as a clinical rapid test. So instead will be take more time for pathology for CT scan. The doctor can isolate their biopsy, then extract RNA from MH1, pre-MT1, and TNT4, and they will have rapid test. So they will be take more time.
The qPCR.
To the qPCR.
So since the cancer have so many factors.
Ulang lagi. Ulang lagi.
Another additional rules are there are no additional slides allowed during the presentations and question and answer session.
Enggak tahu sih, kayaknya enggak.
Start the tournament now. Oh, okay. Okay, okay. Ah, okay. Since everyone's here, okay. We are going to start the tournament now. Before we start, I'm gonna explain about the house rules. So the defender teams has 3 minutes to present their studies, and the attacker teams has 6 minutes question and answer, which included 30 seconds to ask or to attack, and 60 seconds or 1 minute to present or defend their studies. And we encourage each of the participant in the team to be actively contributed, because if there is only one person that actively contributed, the team will be the team point will be minus 1 point if only one person active. Okay, before we start the tournament, we're gonna decide which team will attack first. So you can choose are you head or number, and you're gonna be the head. The one that win will be the attacker, and it means the other team will defend first. So the number is the winning team, and you gonna present first as the defender. Okay. Okay, you can start the presentation now.
Okay, good morning everyone. So we are from team 8. We would like to present our research. Okay, so next. Okay, so gene therapy is a promising approach to treat genetic disorder, and it requires a vehicle to deliver genetic material into the cells. And there's two types of vehicles. There's a viral vehicles and a non-viral vehicles. Recently, However, recently the non-viral vehicles become important because they can overcome the viral vehicles. One of them is chitosan, and chitosan has a good biocompatibility and a potential to be widely used in Indonesia. However, to develop a good chitosan-based nanoparticle that can transfect efficiently into the cell, it requires a lot of resources. Therefore, we create a model that can predict the transfection efficiency of chitosan-based nanoparticle and gain an insight about how to make a good chitosan-based nanoparticle as efficient as possible.
Okay, so we first get around 741 samples from around 400 literatures, and then we perform feature engineering, what results in the final feature of 26 features from around 6,000 features, and then we assign binary class to each sample based on class transfection efficiency result and efficiency analysis method, and then we split the dataset into train set and test set, and then we choose the best model based on classification parameters, because we train like around 16 classification model in this study, and then we interpret the model using Shapley analysis and feature importance analysis to reveal the relationship between key features and transfection efficiency of the model. And so this is the result. It just for the note, the poster is slightly different because I miss. This one is like it should be reversed. This is the extreme gradient boosting classifier with this matrix like here, and this is the random forest. So we made a pretty promising model because we have managed to get 80% on accuracy, and then 90% on AUC, and around 83% on precision. So it's promising. And then we also interpret the model, and we managed to find out that To create a ketone nanoparticle that has a good transcription efficiency, it preferred to have higher ketone DNA ratio and a low molecular weight with electron rich on or electron deficient atoms in modified ketone excipient. And pegylated ketone is more preferable. And excipients with low lipophilic surface area with branch or cyclic structure is preferable to create a ketone nanoparticle with high transcription efficiency, which is some of it hasn't been realized yet by most studies. And I think that's about our presentation. Thank you.
Okay, thank you for the presentations. Now we're gonna set the timer for 6 minutes for question and answers. Okay, you can attack now.
Okay, based on your result, I believe that your timer, yeah. Okay, thank you very much. I believe that one of your purpose in this research is to construct a vehicle, right? And then I like to ask whether you already consider all parameters about cell type, something like this, or the way how ketone will be uptaken by the cells. Do you know about this or not?
Yeah, I know.
And then could you explain?
Okay, so we already considered like cell types, but in this study, because it is still, if we only consider cell types, then it might consider like it might create an imbalanced data set. So we didn't include the cell types in our prediction model. But according to other studies, which has done something similar before to us, it actually the physicochemical properties matters a lot more compared to like cell lines. And according to the how it interacts, that's why we only use ketone model, because if we consider that too, it will make the model a lot more complicated, and it may be like more trickier to build. So we just normalize it by only taking ketone dataset and let the model predict the other things about the interaction, and then we can get the result on transformation efficiency.
Yeah, but do you know what is ketone? It's a biomolecule of what? What kind of biomolecule is ketone?
It is derived from chitin from the fish.
Biomolecule is carbohydrate, lipid, protein, something like this.
It's a carbohydrate.
It's carbohydrate.
Yeah, of course. And then we know that certain biomolecule will be uptaken by cell based on its receptor. So I believe that the study on the cell types, because they have different receptor, it's important in this study. You have to collect all the data of this before creating the ketone as a vehicle for any gene content. It's still important, I mean.
But yeah, but other studies, if even though that they actually also consider ketone in their data set, and they still manage to get a good result. That's why we follow them, because if we also include cell types, it will be disadvantageous to us, because I try it, and it actually creates a bias in the model, because there are some cell types like the HEC type that is constantly being tested into. So there is like very, very low other available data on other test type, cell lines. So we try to, how do I say, bypass that by using this method.
So, but I still believe that we still have some more result about cell type that has different receptor for ketone.
Yeah, but currently the data is still unavailable, so we try to bypass it using this method. Yeah.
The gene-based therapy, but I kind of odd for me, because you're only focusing on the transporter rather than the material or material genetic that way more important to perform a gene therapy. I mean, like, you didn't explain, you just structure the transporter, but you didn't study about the physiochemical, the interaction between the transporter and the material genetics, and also it could be lead to the traffic. Yeah.
So we didn't consider, but not exactly that we didn't consider it, because in ketone it is well known that ketone nanoparticle is like well suited for lots of materials, and most of the materials used are like similar, like they use luciferases so they can detect it. So we try to bypass this by only focusing on the transporter, because we assume that the transporter is well suited to most gene materials.
That's exactly my point. I mean, like, if you're focusing on the transporter and not focusing how the transporter will interact with the material genetic, it could be any material genetic will be affection. So even though you're able to deliver the material genetic to the cell type, but it cannot work anymore because that could be an intervention during the time when the material genetic is carried by the transporter.
Yeah, I think that's the limitation of study, but that's why I only use chitosan in this study, because if we consider other nanoparticles, then it will make us consider the interact more and more. But if we only use chitosan, then the model can predict whether how generally chitosan is involved in the cell, and by doing that, we can prevent the model to we can just bypass this issue.
Okay, I also want to highlight that we develop a chitosan based on the particle. So we focus to develop the vehicle first. After we get the optimized vehicle, we will consider about that. But in this research, we will focus to develop the vehicle first. That's why that's the aim of our research. That's why we didn't consider about another interaction, but because we want to focus to make a good vehicle first. That's the reason why.
The point is, you coming from the previous research, right? You coming from the previous research, which is, it could be different interactions between how the result between the first transporter with chitosan, the material genetic inside could be different from one paper to another paper, and then also what Pak Kuku mentioned here, it could be different also the result between the cell type that you want to infuse. So it's like it could be biases because the
So I actually use this because based on like other studies that I mentioned that make the similar thing, they also don't do that. They also actually make a very good how do you say, approximation.
Time's up. Thank you so much. We're gonna have a 1-minute break before we continue to the other team's presentations.
Okay, so honorable judges, ladies and gentlemen, have a good day. My name is Lawrence and this is Pak Kuku. We're going to discuss about developing G6PD silencing in invasive lobar carcinoma using IVA CRISPR. So introduction is breast cancer is the most common subtype cancer in globally, prevalently. And then there are several types of breast cancer, and we're going to discuss today is ILC because it have a uniqueness, moreover in therapeutic resistance. So to deal with it, we use a different approach, which is using G6PD, which is a very useful enzyme in the cells to deal with the ROS or oxidative stress, and even more crucial effect on the cancer cells, because that's the reason why cancer cells are able to survive even though it's high ROS. To interrupt it or to deal with it, so we use a IVA CRISPR technology to interrupt this kind of pathways so we can deal with the ILC. So the method is we use 5 types of cell culture. The first 3 is ILC. The rest of it is a normal cell and immortal cell ILC. We divided our project into 2 phases. First phase is using CRISPR-Cas9, and then the second one we use the IVA CRISPR. The difference between these 2 phases, rather than except of the Cas itself, is the transporter. With the first one we use lipofaction, and the second one we use LNP. And this is the result. This is just a confluence of the cells to make sure the cell is growth. And the result is, this is the G6PD expression and activity before it's mediated with the Cas, which is you can see consistently that in cancer cells have a high level of G6PD expressions rather than the normal cells, both in an mRNA level, in a protein level, and also the extractions of the protein, which is the enzyme. And this is the result after it's mediated with the CRISPR-Cas, which is, as you can see, it's constantly or significantly reduce the expression of G6PD gene in all type of cells that we have, and also in all type gRNA candidate that we have. So it comes to the next step, which is the designing of our new IVA CRISPR technology. We focus in these two action. This is the gRNA, and then this is the target score of target score, and this is the in silico result to make sure that our IVA CRISPR is a same construction with the most common Cas how supposed to be. The point is the hairpin loop is exist. So the conclusion of our study is our prior is have promising when we mimicking the CRISPR-Cas9, when we're going to do the further research using the very new type of CRISPR, which is the IVA CRISPR. That's all, and carbon cup.
Thank you. So now we have 6 minutes question and answer. Can you please start the timer first? And you can start to attack now.
Okay, first of all, I would like to ask, why did you choose LNP instead of a newer generation of lipid-based nanoparticle?
So basically, we're using LNP because it's the most safest transporter that we have so far. Because as you can see, as LNP is made from lipid and cholesterol, right? So even though there is a consideration, oh, it could be used affected the liver and it could be the fat. But yeah, when you do it in a clinical way, the amount of the substance that you injected in the body is very low. It's same thing as you are do a vaccination for COVID-19. It's only limited amount, right? So we consider it because it's a safe, rather than using a virus, rather than using even like a ketosan could be an allergen for several people. But for LNP, it's will be more safe. Moreover, it could be more specific to the targeted, which is cell rather than the normal.
No, I mean you say it will be safer, but there's a newer generation of lipid-based nanoparticles such as LNC, like nanostructured lipid carrier, that may be safer instead of LNP. Why don't you use an NLC instead of LNP?
Okay, so yeah, the newer generation doesn't mean it means more stable structures, right? Yes. Because that's also the consideration. Because as you see, the IVA is a very new CRISPR as well. Now IVA is still under construction to make a very rigid, to make a stable structures. So if we combine the under construction CRISPR with the under construction transporter, it will be how to say, the efficacy of doing the transporting, it will be very unpredictable. But if you're using the well-known LNP, then it will be cover the problems.
Or in fact, the NLC has a more stable than LNP because they consist of solid lipid and a liquid lipid. Instead of LNP, just use a liquid.
In which type of CRISPR?
Actually, they can inject another type of gene, not just CRISPR, but another type of gene, because they can stabilize the genetic material itself, because they contain the solid liquid and the solid lipid and the liquid lipid. So that's the reason why I want to ask, why don't you use the NLC instead of LNP, because they have a more stabilized form to carry the genetic material.
Yeah, for my opinion, this is the setting we already think it is the best based on the result, because IFA CRISPR is the recent one, and then we have to establish using the known LNP already, the lipoprotein already, the well-known already.
Actually, LC is a well-known, is a well-known and the newer generation and the more stable one.
Yeah, that's why I asked in which type of CRISPR.
I don't know about the CRISPR, but they can carry a lot of genetic materials that already a lot of research doing that. but I haven't read about the CRISPR. But they prove they can carry a lot of genetic material with this NLC in a lot of staples.
Okay, regarding of that is following our discussion back then that the transporter also able to contribute to the changing of the material genetic. It could be like a physiochemistry within the transporter and the material genetic. So based on the research that we have that we doing review, the LNP have a record that able to transport the CRISPR. So that's why we don't want to make a bias. If there is, if the IVA have no efficacy, it could be have two options. Either the IVA is not working, or maybe the transporter is not unable to working well with the IV CRISPR. If we use the transporter that never been associated with the CRISPR. So to avoid that kind of the biases at the end, so that's why we use the most relevant transporter.
So how do you characterize the quality of this LNP, like the stability and then the intake and then the release profile of this LNP?
Perfect. So basically, that's where our research is stuck for now. We don't do this right at the end nowadays, because we have a problem when we doing combination between IVA with the LNP. It's not because of the CRISPR itself. It's because the type of CRISPR that we're using is it's a very new one type of CRISPR. So we don't do the efficacy of how the effective yet, but we'll go do it in the near future.
But then how do you justify that all of this is caused by the CRISPR release from the LNP? Because maybe the result from this is caused by other things. Maybe the CRISPR never released from the LNP.
So our result that I showed back then is not this, it's from this. So it's not LNP, it's the life of actions. So it's the life of actions that able to deliver the CRISPR Cas9 to the cells and give the result of the reduction of the G6PD to all the cells. So it's not LNP, it's life of actions.
You know they can deliver efficiently because you cannot include the transcription efficiency of the cell. How can you make sure that how can you make sure that these can answer now?
Okay. I don't understand why you're questioning about the efficacy, because the result is show that down regulation of G6PD reducing enzyme activity in all the sample with all the gRNA that we have. If you're going to point out about okay, we know that it will not efficient, but you can see it in this one. It anyway able to deliver. If unable to deliver, then the result will be not significant on regulation, isn't it? No.
Thank you very much for everyone. And now we have the winner for this tournament, and the winner is Team 74. Congratulations for Team 74 once again. Okay, thank you so much for the judges. We can take a break now, and we will meet again at 1 p.m. Plus or minus. Plus or minus, okay.
Makanya kemarin tuh saya baca, wah sama-sama nanopartikel nih.
Would like to invite group 68 to sit on the left side and group 42 to sit on the right side. Okay, before we begin, I would like to remind the rules again. The defender team will have 3 minutes to explain about their study, and the attacker team will have 6 minutes during question and answer sessions to attack other teams' presentations. And during 6-minute question and answer, the attacker have 30 minutes to point out or critics about the study, and the defender teams have 1 minute to defend their studies. Before we start, which one do you like, head or number? Number, okay, and you will be the head. And the winner will attack first. Okay, so the head wins, and the other teams will defend their presentations first. Okay, the timer. Team 42 will defend their presentations first. Oh yeah, I would like to remind as well, during the presentations and question and answer, please use the microphone to answer and give questions. Okay, would you like to try the clicker first?
Check. Okay, it works.
Okay, so you have 3 minutes and it is start from now.
Okay, good afternoon, ladies and gentlemen. My name is Yaakob Slowina Sidaga. I'm here with my partner, Diatni Fauzia. We're here to present our paper entitled Effectiveness of Rotavirus Vaccination on the Incidence of Diarrhea in Children in Panghegar Public Health Center, Bandung 2024. Okay, so basically, as we all know, that rotavirus significantly contributes to childhood mortality, causing 39% of global diarrhea. That's in children under 5. And furthermore, when we look at the data, then in Indonesia, at least to 45% of infant hospitalization for acute watery diarrhea. Well, the government did something. Okay, in August 2023, they launched a vaccination program. Vaccinated over 196,000 babies, but coverage goals must admit. That's why we need to. That's one of the reasons why we did this study. And then our study is a case control study design in which we have two groups. The first one is those with diarrhea, which is in the case group, and the second is those without diarrhea, children without diarrhea. From the Panghegar Health Center, we receive a data of around 37 children aged 12 to 59 months, which they were diagnosed with diarrhea from the month of February until May 2024. But then we need to exclude around 8 of them because 3 of them were not at home during our despite multiple visits, and 5 of them moved to another address. Hence, we have 29 samples, and for the control group, we have 1:2 ratio, in which we get the address of each case group respondents, and then we pick the control respondents 10 house spaced apart. Okay, next. And then these are the results. The first, the study shows that there were disparities in vaccination rates across the dose, which with higher uptake in control groups for the first, second, and third dose, and it shows that there is a need to improve vaccination strategies. And then furthermore, we have the results here that rotavirus vaccination can prevent the incidence of diarrhea in children by 1.86 times after adjustment. And then it means that any improvement in vaccination status will prevent the occurrence of diarrhea. And the results show that the significant difference in the odds ratio among the balance education, age, occupation, and type of caregiver at home. Now, the conclusion of our study, it says that vaccination coverage was significantly lower in children with diarrhea or case group compared to those without. And the rotavirus vaccination reduced the risk of diarrhea by 1.86 times after adjusting for the age of the children. And it highlights the need for a public health strategies to increase rotavirus vaccination coverage and ensure timely administration, especially among the vulnerable groups. So thank you for your time.
Okay, thank you for the presentations. We will reset the timer for 6 minutes first. and you can attack now.
Okay, thank you for your presentation. I think that's a nice presentation. So I want to ask you about how were potential confounding variable example can you show about your difference? Okay, sorry. For the first and the control with the homes before. Yeah, this one. Your sampling method maybe. Okay, because I think the first house and another house have different factor because their nutrition status, water sanitation, it's different.
I got your point. Why we choose the sampling method, dispersed in 10 houses, right? Because we believe that if we choose dispersed in 10 houses, about 10 houses itself, there is we look some environment. There is no difference between the case and the control group, and then especially for the communal facilities like what's that, Jamban, and then how far the respondent to reach the health facilities. So we use the spirited intent houses, look for the same environment between case and control group.
All right, so for your research, you are using case control, right? So you have to match the one vaccinated and not the one having diarrhea and not having diarrhea. So what's your parameter to decide that these two subjects are matched?
Okay, so we use the data from the Puskesmas in which we ask for the children with a history of diarrhea. So we get it from there from the month of February until May 2024. So from that period we get the data and we get their address. That's how we get the supply method and also how to match between the case and the control group.
So for the matching you are only using whether this kid ever having diarrhea or not.
No, for the matching itself, there is additional inclusion criteria for the control group between the case and control group. The first is the sampling method itself in houses, and then the second is about the age of the control group. There's about 6 months.
Have you considered any confounding criteria like what my pater just asked, like the economic factor and the nutrition and etc.?
Yes. There is some education for the family education, and then why we choose the inclusion criteria with 6 months about the case and control group. There is we believe that there's the age of the case itself has a confounding because there's a confounding that can be show in our table.
All right, so next for the case, for the sample, you have 29 and also 58, right? Is it representable enough? Because I think it's a rather small amount of subjects.
Yes, we believe that is presentable because we have total sampling for our method. So because it's total sampling itself, we believe that if over 60 samples, it have a huge population, a huge sample for the case and control group.
How do you make sure that it is representative enough? What's the validation?
Because we have read some previous research that for the case and control group in the diarrhea itself, there are so many perbandingan with case and control group, comparison case and control group 1.1 and 1.2, especially the average of the research previous is 1.2, and then this is we believe this is good for our research because there we have a total sampling and comparison to on case control.
All right, can you move to the conclusion? So before the data, before conclusion, after this I think.
Conclusion.
Before conclusion.
No,
before the simple one.
This
There's this OR 1.86. So in my knowledge, OR there is a risk factor and protective factor. So this is vaccination, so it has to have a protective factor, and this is the amount is more than 1. So it's a risk factor. The fact that they are vaccinated.
Oh, okay, I can see. Yeah, thank you for pointing out. I think we should. It's a mistake that actually this is not the PowerPoint that I revised. We should have just paraphrased the statement over there to say that actually those with vaccination have lower 1.86 times lower chance to get diarrhea rather than we need to paraphrase that one.
Oh, so it's not the OR. So is it really the amount, the value of the OR or not?
Yeah,
Because
the value is there, but then the paraphrasing, the statement should be paraphrased.
how about the beta power beta calculation to no, 0.2? So the desired one, in my knowledge, should be around 0.8 or 80%. It is far lower than the desired effect. How is your explanation for that?
For this model, we can have look for the OR and the p-value. P-value is significant. For rotavirus vaccination, it can explain for the area, can prevent incidence of the area 1.86. And then for this model, we can see that the rotavirus vaccination 85% to explain the model for the diarrhea itself.
I see, all right. Karena dingin ya, jadi kayak gampang kering.
Okay, good.
Okay, thank you for the opportunity. From here, I'm Dion Saputra and my partner Devi. We have the research with the title is Bioinformatic Based and Molecular Docking Study of Marine Actinomycetes Antibacterial Mechanism Against Multi-Drug Resistant Bacteria. So as we know, the antimicrobial resistant AMR is the emergent as one of the top 10 global public health threat. So we must solve this problem with, as we know, the marine source is very potential, especially in actinomycetes is known for its potential as a source. However, mostly people use the terrestrial, but in here we specialize to marine source. And the traditional drug discovery method is deemed ineffective and economic unsustainable, so need a new approach for solve this problem. So using the bioinformatic and molecular docking approach offer an alternative method in drug discovery with a predict. And the method we use the marine actinomycetes genome were collected for MCBI database. The structure of protein target were acquired for SCSB, and the ligand structure were acquired from PubChem, and this is software we used before. And yeah, we're using two species in here. We use the Salinospora toprica and Streptomyces. And this is for a lot of ligand, BGCS. We using more potential highest from this species. We using 5. And this is the result of molecular docking. As we know that in here, the salinolactam and naringanin highest, more better depend on antibiotic or contrapositive. So this is the result of bones or our source or potential compounds, and this is the DFT result. So we're using for now the stability from our new drugs compounds, and this is the result of ADMET prediction. So now this is a candidate to be new antibiotic, and this is salinolactam and naringanin. In conclusion on our study is this study demonstrate marine actinomycetes derivative compounds so antibacterial potential against MRSA. Salinolactam and naringanin are the top candidate based on binding affinity, ADMET, and DFT result. I think enough from me. Explore marine biodiversity for human welfare. Thank you very much.
Thank you very much. We will
Okay, thank you so much, Mr. Dion, for the nice presentation. But there are several things that I would like to ask you, or maybe for clarification, because I learned a lot from your presentation. So first, why did you choose the four ligands? Are there any ligands out there? The four, oh, is it five? Oh, sorry. I mean five ligands.
All right, thank you so much for the question. So from the anti-smash, we have the 20 and also 35 BGCs, right? So we choose the highest similarity and we drop it down into the 5 compounds based on the prior bibliometric study, because we know from those compounds are less explored or less research, especially about the antibacterial potential. As you can see here, that the amount of research is very, very limited. Some only have 16 or 15 publication, and the more research compounds are not about the antimicrobial potential of said compound. So we are trying to explore the antimicrobial potential of those less explored compounds.
All right, so what's criteria that your team used to consider a docking result as this is better than this one, this is better than the control?
Right, so this is the docking result. You can see here, this is the point. And the one in yellow is the docking between the proteins and also the antibiotics, common antibiotics we use. We can see here that the compounds highlighted in green have better score than the control positive. More minus means better binding affinity or stronger binding affinity. Based on this, we can conclude that almost all of these 4 ligands we use have better binding affinity than the control.
All right, for salinylactam itself, there is under the control. Why you choose the best is salinylactam?
This one, salinylactam. Yes, this is less than control against the protein M5M18, or you can see here again protein targeting in cell wall synthesis. But if you can see, we docked it also against the protein target in the NR application, and the result is better than the control. That's why we choose the salinylactam, because it still have better binding affinity, just targeting the different protein. It means they have different mechanism.
But for the question, so when we talk about these 3 protein targets, these 3 are they the most relevant for the MRSA survival, or why did you choose only 3?
Oh yeah, because MRSA have many mechanisms in combating the antibiotics, and there are many mechanisms in antimicrobial system, you know. We choose these 3 because these are the most common used in our common antibiotics. So this is the most common mechanism in MRSA. That's why we are targeting this. And the other mechanism usually do not include protein target. They use efflux and PAM and etc. And there is no protein to dock. That's why we choose this main mechanism.
Okay, yeah, and in your introduction, you mentioned that traditional drug discovery method is deemed ineffective, economically unsustainable. Wait, is it? Yeah, unsustainable. But then the source that you use is 2010. My question is that how do you revolutionize this industry?
All right,
I mean,
so
from the study that you have.
Yeah.
What changes what are the promising things besides these 3? Are they necessarily change the discovery method?
Okay, thank you. So the traditional drug discovery method is that from, for example, for marine actinomycetes, we have to manually, screen the compounds using wet lab study to know what compounds is there in the marine actinomycetes, and it takes a lot of time and a lot of resources. When we use bioinformatics, it's revolutionary because without having to do the wet lab, or just with only the database existed, we can predict what are the compounds existed in those in the actinomycetes metabolism, and we can choose, or we can make our target is more precise rather than just preliminary or screening from so many compounds.
Okay, so is a small difference biologically for your team means meaningful. I mean that there is means 7.5 and then 7.0. How far there's meaningful of the point itself?
Okay, so for docking, commonly when you are more minus, for example, if your result is more than -7, for example, -8 or -9, it means that it has more strong binding affinity. So in this we have -7, and in this we have -7.5. This means this one is stronger.
Yeah. So, but when you say more stronger or more strong, it means it's stronger than the control, right? Or are there any threshold that using when you interpret whether it is strong or weak?
Yes, this is we compare it to the control. Yes.
So for the last, why you choose salinactam and lingering if there is a harmful for our body?
They're not harmful for our body because based on Atman analysis, this is past the Lipinski rule of 5. It means potential. It deserves to be developed to be oral drugs, and for the toxicity, you may be concerned with this harmful if swallowed, right? So this means that this can still be consumed. Just the dose has to be adjusted again. It doesn't mean it can be consumed.
But how about salinosaparamid A?
Salinosporamide, we do not use it because even though it passed the Lipinski, it doesn't have strong binding affinity.
But the difference is only what? Oh,
The binding. So it's still better than.
So we conclude for some validation for using this for new drug discovery for human.
Okay, time's up. Everyone, it's a tie. So we will have an extension for 4 minutes. Each team will have 2 minutes to attack and defend their presentation. So we will start from your team.
I'm attacking or I'm defending?
You're attacking first.
I'm attacking your team. So, and the PPT will change?
Okay. Oh, sorry. I guess it will be better if you will be defend first.
You can continue.
Okay.
Any question from you?
Okay. So you can start to attack from now.
So we can go to the next presentation.
This?
Next. If you choose the salinactam and renal thing, there is time for body. So how we can comparison about the salinactam and lingering itself? How full for compare our body? The about that comparison with the control.
All right. So we know that from this result that the naringenin and also the salinilactam have better binding affinity. So how do we know it is also safe for our body? So we do the ATMET analysis and also the DFT results analysis. The DFT results shows that the salinilactam, they have 3.3 and also 4.9. This is considered to be stable because their energy gap is a bit more higher than the other compounds. And last, we also do the ATMET analysis. They pass all the Lipinski rule of 5. This means that they are potential to be developed as oral drugs.
Maybe for the control, there is from the government have the control that's for mild for our body. So that's they not use the salinilactam and lingering for because they have harmful for the body from the control. Is that maybe?
I still don't think I get your question. Can you please repeat that?
Maybe for if you use from the binding itself affinity,
yes,
there is a good from better from the control group, and then maybe there's if you use this one, and then if we compare about the ARMET itself, maybe your result is we don't believe that it's more. We believe that it's more toxic than the control that still exists in this.
All right, so that's also the limitation of our study. So what we are doing is bioinformatics is basically prediction, and even though it's prediction, we are using algorithm and standard algorithm that being used by many people too. So it's a pretty accurate prediction. However, we still have to do wet lab analysis, right, to make sure that this is safe, and that is the recommendation in our study. So the next step, we have to conclude a wet lab to make sure that this is safe, and mungkin maybe do further bioinformatics study to make sure there's this thing called molecular dynamics, so we can know for sure how the drugs and the compounds and the protein interacted in real time, so we know whether if it's safe or not.
Okay, thank you very much. We gonna change slide. Could you please change the presentation to the other things?
All right, so can you please go to the result of the table? The one that there's the confidence. All right, no, the confidence, the table one. This, so the confidence CI, there's this interval 1.2 to 10, so it's like a big interval. Can you explain what does it mean? Why does it have such a big gap?
Yes, this is interesting if we talk about the CI itself, because we have a total sampling, and then we believe that it is enough for our sample. This the CI itself is effect from the sample size, but we have already controlled the sample size with the total sampling. So this is just the result of statistic in the software.
But the statistic is important, right? If you have like such a low confidence level, then we cannot be sure whether this study is profound or
Alright.
validated.
Yes, this is maybe the limitation of our study, but we have control it with the total sampling on our method.
Can you go to the next slide, please?
Next slide.
Yes, there's this also the OR. So there's this mother occupation employed. They have OR 11.66. It's such a high OR. Can you please explain that, since you have mistake in the mother occupation employed 11.66. So can you explain that?
Continued interval. It's just continued interval. All right. This is the OR in this table 2 is show us that there is stratification between the confounding and then the modifier effect of this our study. So of this, yeah.
Thank you. Dengan saya belajar Aquaman.
Kita juga belajar public health.
Jadi apa tadi kalau public health? Menkes. Belajar segini.
Okay, so is team 6 is already here from cycle 1? You can sit on the right side, and team 79 from cycle 3, you can sit on my left side. Okay, we will start our tournament now. Before we start, I would like to remind again about the rules. Each team will have 3 minutes to defend their presentation or study, and the other teams will have 6 minutes question and answer, which include 30 seconds of the attacker to give their comments and 1 minute for the defender to explain about and defense about their study. Before we start, I want to remind, please use your microphone whenever you ask questions and give commentaries and present. And also, before we start, we would like to choose which will be the one that defends first. So the one that win will be the attacker first. Okay, so which one do you like to choose? Head? Number, okay. So you're going to attack first and you're gonna present about your presentations first. So team 79, are you ready? Okay, would you like to check your clickers first? Okay. Okay, and you can start your 3 minutes presentation starting from now.
Good afternoon, everyone. I'm Ulfana Jamudin, and my friend Andi Mamurudana going to present a scoping review about interconnected genes and dietary components in type 2 diabetes and obesity, and we call it diabesity. Why we call it diabesity? Because these two diseases are interlinked through complex gene-environment interaction as core elements of metabolic syndrome. And as you can see from the graph here, there is a trend line that parallel between these two diseases. Next. There are a lot of studies related to obesity and then type 2 diabetes. However, most of the studies are discussed separately. So there is also inconsistent evidence related to gene-diet interaction. So this scoping review gonna bridge the gap. Next. So the objective of the study first is to map genetic variants associated with dietary patterns and their relationship to obesity and type 2 diabetes. And the second is to identify the key genetic mediators linking dietary factors and to psychological alteration underlying diabesity. The methodology using in the scoping review will be based on PRISMA for scoping review framework that already registered at OSF, and the database used from PubMed and Medline. And the study included in this review, including the clinical trials, observational studies, and experimental research. Next. And these are the PRISMA framework that we collect the data around as much as 8,571 of studies from PubMed and Medline, and then end up with 17 studies including in the review. This is all the studies that included in this review, and these are the results. So on the left side, you can see here the Sankey diagram that illustrates the genetic variants on the left and associated with dietary response in the middle, and then their potential links to obesity and type 2 diabetes. And the metabolic line width represent the number of gene diet associated contributing to each disease. And from this data, we derive 4 key genetic variants connecting obesity, type 2 diabetes with dietary modulation and psychological impact. So we found 4 key genetic, including TCFL2, FGO, and MC4R and RS1. These are interconnected each other to diabesity. So this finding highlight the potential of genotype guide nutritional strategies to improve prevention and management of diabesity through although further research is needed to validate clinical application and address polygenic complexity. Thank you.
Okay, we're gonna reset the timer first for 6 minutes.
Yes.
Okay, first, why you use diabesity terminology? Because we know it's a different condition between diabetes.
Yeah, actually that's common terms used in many research combining type 2 diabetes and obesity because they have a similar mechanism in terms of the risk factors. That's why we chose that.
Okay, thank you. If you say it's a common terminology, but then in your Sankey diagram, it's clearly separated between the diabetes and also the obesity. Why? If you say the same way, it is like separately different.
Yes, I think she's pretty much mentioned about the gaps that we want to address is most of the studies showing the genetics and diets and obesity problems and also separate from type 2 diabetes. What I mentioned before that common practice is this is already been acceptable term in diabetes in metabolic research, the terms of diabetes. Yeah.
Okay. 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 Then I want to ask about in this methods you said about we have 17 studies, but in abstract I look at it, I see 18. So what? How many papers?
Yeah, actually 17.
Actually
We mistyped because we exclude one studies and then we forgot to change the abstract. Apologize for that.
Okay, then I want to ask about from these variants, there are like dominance linked to obesity, but it's too small linked to T to the M, type 2 diabetes mellitus. And why there are the obesity is so dominant in this Sankey diagram?
I think because our keywords including obesity, type 2 diabetes, and also related keywords like metabolic aspect, kemudian, and then body compositions, and then weight loss, insulin sensitivity, that's direct related to obesity. That's why we ended up with findings many obesity studies. However, when we look deeper into the studies included, actually there is some connections between obesity and type 2 diabetes. It means that in one study included two outcomes of the disease, obesity and type 2 diabetes.
Okay, then I want to ask again about how you convince us if you don't preserve the how proportion that correlated with type 2 diabetes and how proportion paper that correlated with obesity, because there will be bias because the imbalance of paper.
I think that's not bias, because bias is a systematically error that we that occurred during extraction. But I know what your concern, why we end up with obesity more than type 2 diabetes. Yeah, it's because actually our research questions just to answer the relationship between diabetes, obesity, and genes modified by dietary factors. So it doesn't matter if we end up with unproportional
Papers.
Not papers, studies between these two diseases. You still can answer and use the information from our studies.
Okay, then I found some inconsistent from your results. Like this is from the key gene variants. We said that these are SNP RS7990 that correlated with T to TM. But in Sankey diagram, we don't see these variants on this linked to T to DM and others like obesity like RS9939 that also non have correlated with TDM. This also MC4R, MC. Okay.
Yes, actually, yeah, you
here.
can see here. This is NIPS from TCF7L2 associated with obesity, but there is a total energy also related to insulin mechanisms. That's why we included this as a disease associated, because whenever total energy modified or altered by these genes and it's related to insulin mechanism, then we can categorize is still have association with type 2 diabetes. So this is our discussions, and we found that strongly related to this SNPs.
So I think if there are inconsistent, so what should I percaya?
believe is in this variants, this key gene variant or this Sankey diagram.
Can you define what's inconsistent here? Because I already explained that these SNPs related to obesity, that's first. And second, these SNPs related to total energy, and total energy related to insulin mechanism, which is directly go to diabetes mellitus.
But why it's not clearly stated in the Sankey diagram? Yeah.
Because too many variables that related to that, and we cannot ensure. If you want to put another mediators variables here, then there should be correlations. But since we only want to identify the
Oh, sorry.
Would you like to try that here first?
Oh yeah, sure. Okay, good afternoon everyone. Now I'm going to present my research is about lasologistic regression and artificial neural network for prostate adenocarcinoma metastasis, prediction and biomarker discovery based on the gene expressions profile. Go to the introduction. So prostate adenocarcinoma or prostate cancer leads the fourth most prevalent cancer among men in Indonesia, and it frequently advances to metastasis. As we know, metastasis detection only relies on histopathology and CT scan, which takes time and costly. So the research objective is first to develop a machine learning model for predicting prostate cancer metastasis using the gene expression data, and also to identify the key biomarkers leading to the prostate cancer metastasis. For the method itself, we gather the data, which is the RNA-seq data from the TCGA, and then we do the cleaning and also imputation data. And then we do the normalization. After we gather the significant genes, we started from the feature selection 1, feature selection 2, and started to do the machine learning analysis and validate it with the biomarker analysis. For the result, feature selection 1, DAG, several genes are significantly downregulated in the left side and upregulated on the right side in metastatic prostate cancer. And for the distribution data, it shows distinct gene expression patterns within the metastatic, which is the red dot, and also the non-metastatic, which is the yellow dot prostate cancer sample. And this clear separation indicates significant difference in the genes expression profile. And in the future importance, we use lasologistic rather than random forest because it shows the best performance. And then we identify 7 key genes and selecting 3 of them, which is MYH11, PRMT1, and TANT4A. And then we validate our data using the cross-validation and external validation. In the cross-validation, SVM performs well, but in the external validation, SVM doesn't perform well. So that's why we use the ANN as it is the best performance in the external validation. And to validate also our biomarkers, we search for the pathway analysis, which is MYH11 is downregulated in metastasis, PRMT1 upregulated in metastasis, and TANT4A upregulated also in the metastasis. For the conclusion, lasologistic regression outperformed random forest in feature selection, and also ANN or artificial neural network achieve high classification performance during the external validation by using only 3 biomarkers. And these 3 biomarkers, MYH11, PRMT1, and TANT4A, are associated with metastasis induction through the cytoskeleton disorganization, EMT promotion, and also mRNA stabilization. And the limitation itself, this study only relies on RNA-seq data from non-Indonesian patients due to the limited available patients data in Indonesia, and also it requires more external validation by increasing the data set size. Thank you.
Thank you. Thank you for your presentation, and then it's really interesting result. But I'm wondering, how did you do sample collecting, and then how you maintain the DNA quality? Because maybe if it's across the time, maybe you need to have like special treatment to prevent the DNA degradation.
No, actually we gathered it from the atlas, from the TCGA, which is the atlas we use in the cancer. So we gather 52 the normal tissue, 592 of the non-metastatic prostate, and 99 of the metastatic. So we don't we don't do the wet lab, we do the dry lab instead. Yeah.
Okay, thank you. Okay, regarding I want to ask about the future implication, the practical implication of this result. Yeah, how you gonna use this result for future clinical practice?
Okay, in the future, if there are data that from Indonesia, we can use this model as pre-trained. So we retrain this model with data set from Indonesia. So we don't need so much data from Indonesia. We just need small data to can apply in Indonesia. Yes.
But you mentioned that as your study limitations, that this is probably not representative of Indonesian populations.
Yeah.
So how can you apply the information from this study into the population?
Yeah, so that's why if we someday we get the Indonesian data, which is in the very small sample, we can just pre-train the data, so we don't need like the very big data. And then through the clinical, we can strengthen the biopsy with this kind of model. So like biopsy, we need like 2 weeks, but within this qPCR, we only like, for example, half day to just gather like whether this patient have the metastatic or not. So it's like really potential.
I mean, it's transfer learning. Transfer learning is when we use the small data set to retrain our models, so we don't need much data.
So you mean that your study is slightly advanced than what we have right now? So my question is, I was wondering why these models doesn't implement yet in the current practice, considering the benefits that you mentioned before.
Okay. RNA sequencing also have application in other countries like US and Europe, but yeah, this in Indonesia is more futuristic because yes, we don't have the data.
What do you mean more futuristic, and we don't have data? While you mentioned that you can use the database, etc.
Okay,
Yeah.
the futuristic I mean is the cancer is they move from the profile signature from genetics. So if we use this profile genetics from the cancer tissue or maybe circulating tumor, we can have more accurate prediction. So it will be accompanying the decision of doctor.
Yes, why I asked that, as I don't have much understanding about your area, but I was wondering, we have a high prevalence of prostate cancer, breast cancer, and you can always collect the data from many hospitals in Indonesia, and we also have a technology for using sequencing, etc. So how difficult to implement, I mean applicability of that in Indonesia?
Okay, there are no data because yes, we need more like RNA sequencing, we need like reagent, and we need more sequencing.
Yeah, but
it's too costly.
The tools of the sequencing itself is like not really developed in Indonesia.
Nah, that we developed three biomarkers in this study. So we doesn't need sequencing, we doesn't need RNA sequencing. So we just need qPCR. The result from qPCR. So we just need three primer, and we have the result of qPCR, and we fed into our models. So we don't need RNA sequencing. So it is why we use database from other country.
Yeah, actually, I don't get your answer, but let's move forward. I want to. I have a question about the methodology to identify the enhance or identify key biomarkers. You chose to show PCA. Why I think LDL, linear discriminant analysis, is more appropriate to identify the key enhanced biomarkers among groups. So
No,
what do you think?
no. The PCA is not to really extract the biomarkers. The extract biomarkers is in lasso-logistic regressions. Linear discrimination is non unsupervised. The PCA I use this is to see the distribution of the data. Why we should see the distribution? Because if we want to move to a prediction model, we should see how is the data distribution. If the distribution of the data is so simple, separable, we can decision what model that will be used for prediction model. If the PCA is too heterogeneous, so we need to have decision more complex models.
Yeah, so it's not, so PCA is not used to guide the biomarker, not.
Yes, I understand that, but in your conclusion, you mentioned that 3 identified biomarkers associated with, this is based on your models, right? Sorry?
Yeah.
Okay. And I still wonder what's the benefits of, why you don't just use LDA to separate the biomarkers?
Because
yeah.
LDA just for I don't think LDA I see journal, and LDA is not used for biomarker discovery. And biomarker discovery in this model we use regression, logistic regression, is to extract feature importance. Feature importance is about like many regression have coefficient, right? Or random forest also have coefficient for each feature. So we extract each features and we rank the features rank what feature that have best coefficient, and then this model is have used for most machine learning in biological bioinformatics. Yeah, okay.
Okay. We are going to invite team 68 into my left side and also team 65 into my right side. You can be seated.
Iya, sekarang kita ketemu di meja. Masa dari tadi ketemunya satu cycle kan bosen ya.
Tapi saya udah 2 kali ketemu di satu cycle.
Kami juga 3 kali malah.
3 kali ini.
3 kali ini. Kayak kemarin aja.
Berapa kali match udah?
Sudah baru 2.
Oh, baru 2 kali. Kami udah 3, 4 ini. Jadi ya udahlah, capek.
Dirimu farmasi apa dulu?
Perikanan saya, Bu. Perikanan kelautan gitu kan. Jauh kan. Saya mana ngerti ini.
Ngerti. Justru pertanyaan orang yang beda bidang tuh biasanya agak bikin pusing.
Mohon kepada ibu-ibu jangan terlalu kasar ya.
Astagfirullah. Sejak kapan kami kasar?
Kita diskusi aja.
Mbak, takutnya punya ini kan? Kami juga masih anak-anak.
Ingin banget gak sih?
Hah? Aku juga belum tahu penelitian kamu.
Kita nggak ada nggak sempat baca punya ini.
Kita bolak-balik nggak ada berhentinya semua. Oh, lagi full. Ya biasa lah ya.
Abis ini langsung
atlet. Kejar jam tangan.
Atlet jodoh.
Jodoh. Atlet jodoh gimana, Bu? Nyariin jodoh orang gitu.
Dulu deh.
Ya udah.
Bener, nervous tuh dia ngadepin ibu-ibu.
Astagfirullah.
bukan ibu-ibu lagi, mama-mama.
Oh, gitu. Kan sama
Sebagai
aja.
ras terkuat di bumi.
Mama rempong. Untung nggak lagi naik motor ya. Aduh, saya tiap masuk ruangan kedinginan, kayaknya sampai radang ini saya.
Kayak Indira dong.
Iya, sekamar kan waktu itu.
Oh, jangan-jangan kalian sharing virus ini. Waduh, bahaya. Pindah ke kamar aja. Kosong. Oke,
Oh iya,
siap.
satu orang dong.
Harusnya iya sama
Tidur pokoknya.
ini kan apa namanya, tim pengganti.
Iya, tim pengganti. Jadi kayak udahlah pasrah.
Dokter Ariel masih di sini, nanti dokter Anissa. Tapi perbedaannya lagi makan dulu sebentar sih. Jadi kayaknya
Kita science nih langganan kami. Langganan kami kalau mau sequencing kesana.
sama dong.
Tapi kayaknya mau nyoba, ada sekarang kan Indolab bisa Bu, bisa sequencing ya. Jadi pengen nyoba sih, bandingin lebih bagus mana. Soalnya sekarang nggak tahu sampel saya atau saya yang salah ngerjain ya, tapi kurang bagus gitu picknya kalau pakai genetika saya.
Pakai pandu.
Pakai apa pandu? Itu mana Bu, perusahaan apa? Namanya apa?
Pandu biosains.
Nanti saya minta kontaknya Bu.
Saya nggak punya.
Oh nggak punya.
Cuma tahu aja dia ngasihin juga.
Nyoba gitu.
Maaf, PPT-nya di mana?
Oh bukan itu?
Yang di folder terbaru.
Folder terbaru ya?
Folder Shinjitsu turnamen.
Jadi ini aku yang presentasi gantian.
Yang ini. Yang sebelahnya itu. Yang itu. Bukan deh, klik.
Iya.
Tim 65 PPT kayaknya. Di folder Shinjitsu. Yang paling atas.
Itu tadi di atas 65.
Iya, tapi udah nggak nyimpen di situ. Udah ditaruh yang terbaru tadi. Nah itu. Ini, this one? Ya.
Okay, everyone's ready for the next tournament? Okay, so I'm gonna re-explain about the house rules. The defender teams have 3 minutes to present their presentations, and the attacker teams have 6 minutes question and answer sessions. During that 6-minute question and answer, the attacker will have 30 seconds to deliver their critiques and questions, and the defender teams have 1 minute to answer. And before we start, we're gonna choose which one will go first, and the winner of this coin flip will be the attacker on the first round. So which one would you like to be, head or tail, or number? Tail, number, yeah. Okay, you're gonna be the head. So it's number. It means that your team will defense first. Oh, attack first. Your team gonna attack first and you're gonna present first. Sorry, everyone. Okay, so let's move to... That's okay. Okay, for this team 68.
Can I try this one?
Yes.
Okay, it's working.
Okay, and your 3 minutes presentation might start now.
All right, thank you for the opportunity. I am Devi. I'm with my partner Dion. Today we would like to present our study, bioinformatics-based and molecular docking study of marine actinomycetes, antibacterial mechanism against MDR bacteria. So we know that antimicrobial resistance, or AMR, was one of the top 10 global public threat, and thus there are many drug discovery research being done to combat this phenomenon. And actinomycetes is known for its potential as a source of antibiotics. However, the exploration of marine actinomycetes antibiotic potential is far less explored compared to its terrestrial counterpart. And the traditional drug discovery method is now deemed ineffective and also economically unsustainable. Thus, for this study, we are using bioinformatics and molecular docking approach as an alternative method in the drug discovery. So basically what we are doing is we retrieve a genome of marine actinomycetes from the database, and we predict the BGCs or the compounds that it might produce using anti-smash, and then we dock certain compounds against the protein target in MRSA or methicillin-resistant Staphylococcus aureus, and then we analyze the ligands or our compounds, whether is it feasible to use those compounds and develop it as drugs. And these are the genomes that we are used from Salinispora tropica and also Streptomyces. Both are isolated from the marine source. And here are the BGC's result. There are many compounds we get from here, but we only take 5 main compounds. Those having high similarity to non-cluster and also less explored in terms of its antimicrobial potency. And these are the docking results against some proteins in MRSA. We know that the one in green color, it exhibits higher or stronger binding affinity compared to the control positive, and in this case is common antibiotics used to combat sick. And these are the interactions between our ligands and the protein targets. This is the bonds. And these are the DFT results analysis to know whether is it feasible to be developed as drugs, whether is it stable or reactive. The higher the E gap, the more stable it is, and the lesser the E gap, the more reactive it is. These are the final results from the 5 compounds. We choose salinylactam and naringenin as the top candidates because it passed all of Lapinski rule of 5. Therefore, it deserves to be developed as drugs. And also, it has strong binding affinity, better than the antibiotics or the control positive we are using. So the conclusion is the study demonstrates marine actinomycetes compounds antibacterial potential against MRSA, and salinylactam and naringenin are the top candidates based on the binding affinity, ADMET, and DFT results. Thank you.
Okay, time's up. Thank you very much. Let's reset the timer into 6 minutes. And we would like to remind all the participants that please use the microphone within the sessions. Okay, and the attacker team might start from now.
Okay, thank you for your presentation. I understand that you conduct bioinformatic experiment, right? But I just curious, if we continue your study to wet lab, what method that you will do to extract the active compound from the actinomycete?
All right, thank you so much. So the first act we have to use if we want to continue this into wet lab, first we have to mass culture the bacteria first. Mass culture as in we cultured in a big volume, and then we extract the metabolite using some solvent. So in this case, salinylactam and naringenin is a polar compound. So we are going to use like a polar solvent, for example, methanol, or also we can use ethanol and other polar solvent, and then we purify it to make sure that we remove all the other compounds that is not our target.
Yeah, my question is what method that you will use, because there are a lot of methods to isolate organism, right? Active compound from the organism. There are a lot of methods. What methods that you use?
First, for the general extraction, we're going to use the liquid-liquid extraction, just for the general, for the first step. And then we're going to purify it using TLC, OCC, and also various other methods like HPLC and also HNMR or NMR method to make sure that this is the correct compound that we are targeting.
So in the first, like you will isolate the extract, or later the single compound, or how?
First, we isolate the extract in supernatant, and it's supernatant first, and then we purified it.
How you make sure that you can isolate that single compound, because it's not easy, right? Especially
Yes.
from the marine sample.
Yes, that is correct. That is not easy at all. So in the end of the day, we will use this analysis named NMR. So we know the structure of the compounds we purified. And after we know the structure, we compare to the official structure of salinolactam and naringenin, whether is it the same compound or not.
Could you please explain which, there are 5 compounds, right?
Right, yes. This.
And among them, do you compare to ciprofloxacin, penicillin, and chloramphenicol? Is it a comparison of 1-to-1, or you pull them together, or how is it work?
All right, thank you. So we dock our ligands against 3 kind of proteins, right?
Okay.
These proteins have different positive control. For example, 6FM4, or the protein target in DNA replication, the control positive is ciprofloxacin, because this antibiotic is the one that work best against this protein target. That's why for this, we're using the ciprofloxacin, and this is the penicillin, and this is the chloramphenicol.
But do you know if that compound belongs to any one of these? I mean, in the structure, like, what is it? In the structure, is that compound comparable to cipro, penicillin, and chloram?
In what context, the comparable one?
The structure.
The structure. Of course, we get the structure of the control positive or the antibiotics. That's why we can dock it against the protein target.
Okay. If you would do further with this research, who would you approach first?
First,
the pharmacists, the Ministry of Marine, or Ministry of Health?
Maybe before we move to those big figures, we will search for collaboration in as in our peer researcher, because to develop this kind of drugs, it has to be a collaborate efforts. We have to involve a lot of people and researchers to make sure that our work is correct and is not biased. That's the first step. But if hopefully we can develop the drugs, I think we will approach the health ministry first to inform that, oh, there is this potential of marine actinomycetes that can be found in Indonesia and can be developed as drugs.
Okay, I was wondering the expansion. So that's the actinomycetes that you got from the marine. So you collect them, or you bring it to the lab and expand it in the lab?
All right, for this study, we are using the genome that has been existed in the database, as in we took it from the NCBI. You can see here the strain and the accession number. You can access it yourself and the isolation source. But if we are talking about the wet lab, we also do microbiology in marine, right? So we took the sample, for example, it can be marine sediment, it can be seaweed, it can be seagrass, and then we isolate it in the laboratorium. In the transportation process, we place it in a cool box and sterilize the cool box so it does not contaminate it.
So do you have any rough idea how much actinomycetes marine that will go?
That we will get from the isolation.
Yeah.
So it's very depending on the subject you isolated. For example, if we isolated from marine sediment, we probably could get much more isolates rather than when we isolated from, for example, gorgonian. It's like a soft coral. So yeah, depending on what subject you are isolating it from.
Okay, time's up. We are going to have 1 minute break before the other team's presentation.
Okay, good afternoon, everyone. Today, I'm Ina, and my teammate Anissa would like to guide you through our research in the field of oncohistone glioma. So we know that in Indonesia, the epidemiology of primary brain tumor is relatively rare compared to other solid tumor. However, glioma constitute the second most of the brain tumor. Then it is very heterogeneous tumor that range from the low malignancy to very high malignancy that occur in adult and pediatric. So the 2021 WHO classification of nervous system tumor recommend the incorporation of histology and molecular profile into the diagnostic tools. And from the molecular profile, they recommend to check the IDH and the histone genes mutation, as this will associate with high-grade tumor and poor outcome. So what is oncohistone glioma then? This is the glioma that harbor mutation in the histone genes, and you may see here, the histone is the protein where the DNA is wrapped. And there are 3 different mutations occur in 2 different genes, as you can see here. And this is occur in the specific location in the brain, and then with the specific age and outcome. So we aim to explore the oncohistone profile in Indonesian glioma. From this, we took a glioma sample collected from 2018 to 2024, and we did sample selection based on this inclusion criteria and exclusion criteria. And then from the biopsy, we took the DNA and then did the Sanger sequencing for those 2 genes and analyzed the data. So this is the sample that we got from adult and pediatric, female and male. And then we, the sample from the midline and hemisphere. As you may see here, this is the classification and the location where the tumor was. And using the multiple alignment, we can find 2 mutation in the H3.3K27M and no mutation in the H3.3G34R. And all the HIS1 H3B are wild type. And then we confirm this by checking in the sequencing. And we validate the finding in the NCBI, and this is the result of the summary of all the 3 mutations that found in histone. So by this, we conclude that this is the first molecular evidence, and we hope that it will enhance the diagnostic accuracy based on WHO CNS5 and its potential for molecular-based diagnostic. Thank you.
We are going to reset the timer for 6 minutes. And the attacker team might start now.
Okay, thank you for your nice presentation. So I want to ask you about how will oncohistone profiling actually be implemented in diagnostic routines in Indonesia, because especially in resource-limited settings. Thank you.
Thank you for your question. It's actually also, we need several steps actually. Before we check for the oncohistone, usually we check for the IDH mutation, as you may see in the first here. The IDH mutation, if it's mutant, then we follow this guideline, but if it's wild type, then we go here. But in Indonesia setting, it's indeed resource limited setting. We would recommend that to use simpler method rather than the sequencing, because using, for example, like mostly they use for now in the clinic, they for diagnostic they use the polymorphism fragment restriction, and it's give a simpler method, and then with high accuracy and sensitivity.
Okay, thank you for more. my next question is, how do these two detected H, H3.3K27M mutation influence prognosis or treatment planning in the clinical context?
Okay, thank you for your question. It's actually interesting. Well, in the clinical setting, especially in the Western world, there are several clinical trial is ongoing now. For example, for the H3K27M, the report was released in 2024 based on Arilaga Romani report from the specific antagonist receptor inhibitor, dordaviprone. They reported that this drug can be used to target the H3K27M glioma. So it's a newly diagnosed H3K27M mutation in patient. However, it's indeed still needs more research, especially in the clinical trial. There are also ongoing, for example, like the use of forinostat as an epigenetic therapy by SU in 2021. They also reported the use.
All right, thank you for the nice explanation. I was just wondering, can you please go to the conclusion? So in the conclusion, you claim that this is the first molecular evidence of the oncohistone mutation in Indonesia glioma with the frequency of 9.52%, right? But you are only doing the study on 21 samples and only from one hospital. Is it representative enough to claim it that in Indonesia glioma, this is the frequency? How do you explain that?
Well, actually, from the frequency, we also checked from Castle 2015, if I'm not mistaken, that the frequency of a glioma was about 5%. So with our sample, we can find a bit higher. So we justify that 21 for our pilot is enough. So based on that, in the next step, if we have the chance to do bigger research with more samples, then we will include more sample to have more also multi-center to get better idea of how this oncohistone occur in, especially in Southeast Asian population.
So you said that you justify that from your pile is enough, right? Is there any kind of validation you did, like statistical validation to justify, oh, this is enough?
Well, we calculate the sample size actually based on the mutation rate that I mentioned previously. So based on that, this is what we have now. So we have to deal with this, and then this is what we found.
All right, so the next question is, can you see the graph, between male and female? You present here that the sample comes from female and female, pediatric and adult. Is there any implication from this? Is there any reason why you divide this data to be like this? Is it different, the mutation in women or men, on pediatric or adult?
Well, it's based on the Mackay 2017 that most of the histone mutation first time occur in pediatric. So actually we start with pediatric one, but pediatric tumor it's very difficult to get sample and collect it, so we expand it into adult. So based on those, basically we were working with pediatric tumor.
So there's no implication between the mutations and the classification of gender and also the age?
Well, the implication is bigger in pediatric because in pediatric they still have developing brain, and this is part of the epigenetic machinery which involve in the differentiation part of the brain.
What about the female and male? What's the explanation?
Well, in this case, in general glioma it's more in male, but we don't know yet in Southeast Asian population. But yeah, this is at least this is not gender bias because we did randomize and we use the inclusion and exclusion criteria to select for the sample. So we hope that it's already remove the bias of the gender.
Oh,
Why do we keep winning?
belajar lagi, mundur juga belajar lagi. Aduh ya Allah.
Mungkin tim 11 sama tim 61 mau cek presentationnya dulu.
Ini aman nih, udah yang tim kita.
Udah aman ya? Oke, kalau yang tim 61?
Kita udah 3 kali.
Udah 3 kali ya? Sama iya. Maafin.
Yang di bawah, paling bawah.
Oh ya udah. Oke.
Aman.
Tes.
Waduh, direkam ya?
Masih YouTube.
Oh my god, nak.
Mau masuk TV. Oke, kita tunggu dokter Cita dulu ya.
Kalau kalah terhormat Mas direkam Mas.
Nah, malah malu.
Ya.
Ini dari WUSU. Mahasiswa udah enggak udah. Di WUSU fakultasnya FK.
Tampang-tampangnya udah
Dokter ini ya. Siapa forensiknya? Pak Sam Petrus. Satu lagi ada yang kemarin siapa? Dokter Doaris. Kalau perempuannya. Oh, cowok lagi cowok ya.
Satu lagi ya.
Yang forensik departemen.
Aku cuma masuk ini situ cuma dokter itu dokter doang.
USU.
Oh, USU.
Sekarang bukan dokter Pak Petrus lagi soalnya.
Iya,
Dokter Nando. Ya kenal ya? Ini PPDS apa?
Bisa juga.
Kalau PPDS kita nggak
Iya.
jumpa sama sekali.
Oh,
Ya jumpa sama sekali. Enggak jadi kadep lagi.
Oh, udah nggak
Yang mana yang tadi gitu?
Yang mana? Ya, aku garis bawahi.
Ini sama.
Ini garis bawahi, ini garis bawahi. Kita
Nggak,
tadi
ini
udah
nggak
mau join ninja Shinjitsu.
Sama, kita juga.
Kami juga kayak
Ya udah ninja-ninjaan.
udah Ya, kita langsung aja gitu kita loh. mau join ninjitsu terus ya enggak kamu tanding terus sekali lagi ya
Katanya udah nggak usah harus nyawanya tuh udah habis, justru cowoknya tinggal satu kayak gantung gitu loh. Tapi kayaknya seru. Kayaknya seru memang karena sengaja kan harus.
jadi kita maju mundur kena kan iya kita nggak boleh kalah dengan tenang juga. It's really
Rest in peace itu nggak ada di sini.
iya. Dr. Edward.
Pak Anuraj.
Pak Nuraj juga loh.
Iya,
Nggak
kemarin.
ada di jadwal Pak Nuraj sama sekali nggak ada.
Jadi kita juga yang India itu kan.
Oh iya itu sama Pak Nuraj.
Iya sebelumnya
Iya,
kita.
sama. Yang ini.
Kami dikejar-kejar ya kalau sama beliau. Soal saya dikejar kayak ini tentang apa ini kamu apa ini jelasin dong ini terus kalau kita gagal kamu ngerti nggak sih?
Enggak.
Bentar. Terus
Yang siapa yang itu?
Yang Mas Nuraj yang ngasih itu loh opening speech.
Dia benar-benar
Mas Mbak dari mana?
Aku dari Serang, dari BRIN, Untirta.
Sekarang ini maksudnya mewakili institusi.
Iya,
FK Untirta.
Untirta.
Oh,
Sultan
ya.
Ageng. Nama unitnya doang Sultan.
Rezekinya Sultan.
Amin. Rezekinya istri.
Berarti udah PNS di USU. Oh enggak. Kami first training ya. Sini
Di Bromo 2.
Makanya kita kira mahasiswa.
Angkatan berapa?
Yes,
Angkatan
betul.
2000.
Oke.
Fresh banget.
All right. We are going to start the match again. I'm gonna re-explain about the rules again. So the defender team will have 3 minutes to present about their studies, and the attacker team will have 6 minutes for question and answer. Inside the 6 minutes of question and answer. The attacker will have 30 seconds to give attack, and the other teams have 1 minute to defend about their studies. Okay, before we begin, we will choose who will defend first. The winner will be the attacker, and which one do you would like to choose? Sorry? Tail, okay. So your team gonna defense first. And team 61 are going to present first. Okay. Okay.
Hello.
And you can start your presentation now.
Okay, so ladies and gentlemen, I'm going to present to you about housing distance, salt intake, and cardiovascular risk under Ra Achetamiang, which is an insight from the WHO non-laboratory assessments. So, as I've stated before, in major cities, they have a specialized healthcare, but unfortunately in rural regions, they face significant physical barrier in addressing those cardiovascular disease rates, resulting in less likely to seek preventive care. So, what we will do is a cross-sectional study between March till May 2024 across 15 community health centers using this WHO heat map to predict where are they in the segments of cardiovascular risk, which is specified for the Southeast Asian region. So what we're going to study is also the high and low risk, which is the estimated cardiovascular risk with a high systolic blood pressure, salt consumption, activity level, and also housing distance. So this is the conceptual framework, and this is the result. So we see that there is a high prevalence in females and within the 50 to 54 age range, and then we can see that they predominantly have no smoking history at all, and then the systolic blood pressure is mostly 120 to 139, just on the first phases of hypertension. And then the BMI classification is 25 to 29. So this is the Sansky diagram that most of the high risks are mostly predominantly 10 to 20% of 10 years. And then salt consumption and housing distance is pretty much really significant with a p-value of lower than 0.05 with a high Hosmer and Lemashow's test. So a multivariate diagram here is there is a high housing distance with the moderate salt consumption within the high risk in the middle. And then we can see that in the systolic blood pressure, we can see that there's a significant skew within the higher systolic blood pressure with a high salt intake as well. But if you can see from the distance here, it's mostly dispersed pretty equally, but within the obese, it's mostly concentrated within the 20 to 30 between of the close range. And then also from the age is mostly close to moderate, and with it being mostly skewed towards the close, and the age will be predominantly from 40 to 70. So. Our conclusion is that housing distance and dietary salt intake should be considered to optimize these therapeutic strategies for future research. Thank you.
Okay, thank you. We are going to set the timer into 6 minutes.
Okay, thank you for the presentation. My question is, what measures were taken to ensure the accuracy and validity of self-reported salt intake data?
Of course, it is still there's a recall bias within the salt consumption, but fortunately, we try to make it as simple, as relatable, and as easy to understand as possible when we're talking to the patients itself. So it's instant food consumption recall. Considering that instant food consumption is already high in sodium intake, if you can see from most instant food there is, we can see that most of them are we divide into low, moderate, and high, with high being more than 3 times a week, but moderate within 1 to 3 times a week, and low less, maybe none, if none, per week. So I guess the recall is a bit there is a bias, of course, considering that it's a recall, but it's still very much more relatable and they're easily to understand and to answer. Thank you.
And then how did you control the confounding factor in cardiovascular disease that influenced by other factors such as high fat dietary and then congenital and other factors?
So it is still a very wild confounding factor if we consider like congenital cardiovascular diseases or even fatty intake. But considering that we are using the non-laboratory, because the laboratory assessments actually uses the LDL levels, that is for the fatty intake of the person itself to determine the risk. But if we're using this as a baseline, as a first framework to go up against the cardiovascular risk assessments, this is a perfect start as it doesn't need any lipid examinations, considering that we are also working in a puskesmas that is very limited in resources as well. If we're talking about cardiovascular diseases from a younger age, for example, like congenitals, we are talking about the risk within the framework of 10 years. So most of the cardiovascular risk that is assessed, it is mostly coronary artery disease and congestive. Thank you.
Okay, based on your data, there is a classifying with physical activities, and then how you classify the physical activity to high, moderate, and how you validate the questionnaire to measure that data.
So before we do this, before we acquire this data, we did actually do preliminary studies with the 3 additional data, whether or not it is validated or not. But we differentiate the light, moderate, and vigorous into 3 categories, with light being a regular activity with no sports at all, moderate to light sports to cardio training and maybe walking for 30 minutes, and then vigorous for competitive sports. So it's pretty explanatory for those 3. Thank you.
Okay, and the next, has the WHO CVD risk chart ever been tested or adjusted for people in rural Indonesia?
Yes. So
could give inaccurate result here?
So actually the cardiovascular disease risk, it is very much calculated for the whole of Southeast Asia. They did a cohorts for every single segments and regions of the world. So they have a Southeast Asia region. They have a Southeast Asia region, they have an American region, they have a South Oceanic region. So it's already stratified within the countries itself. And especially within the Southeast Asia that we're using, it's not, although it is generalizing, it is still a very usable and a very viable chart, considering that they're using cohorts from all of those countries and see all of those, data.
Okay, you use method is cross-sectional method. But we know that the cardiovascular disease is long-term disease, right? So why don't you choose the cohort instead?
So first of all, we are still in the preliminary from the first stages. So this is the first data that we have. But also within the cohorts, there is a problem if we're going to do, there's a lot of follow-up, loss to follow-up that there's going to happen. There's going to be a bias to that. All of those data that we acquire now, we can do it for further research, but unfortunately what we are trying to show is within this cross-sectional study is that this is representative to the rural areas of this moment, and we could utilize this as a starting base if we want to dive into and build upon it more. So although cohorts is a much more feasible one, the loss of follow-up.
Okay, that's a continual question. Since the study only look at the one point in the time, how can you be sure which come first, the risks of the cause?
The risks are the cause of this. So basically, this is a WHO to validate the risk. They already predicted this with their own cohorts that within the 15 to 10, below 5, 10 to 20, above 30, that they already did this with their own cohorts, that they already established that of their own course and their own research. So trying to predict this, how is it viable from us? It's just based on the WHO. They're the one who's going to validate whether or not within the 10% or not, within the 10 years, sorry.
Okay, and how did you avoid choosing participants in a way that might skew the result? Yeah, like a selection bias maybe.
We did a random sampling, so we take randomly like the whole entire people that was there. We didn't. Okay, so we did a random sampling of all of those people who comes in, but we already calculated from the sample sizes of Aceh Tamiang itself that we needed a minimum of 371. So we decided we're gonna use a 1,000, considering that the higher it is, the more proportional it is, the more representative it is to the whole population of Aceh Tamiang itself. So the reason why there's no selection bias and why we're confident about this, that we're trying to take every single person without any constricting inclusion rules that may be, biased to it. Thank you.
Okay, this is our research about the optimization of storage time to preserve DNA quantity and purity in max sample through mtDNA analysis. Okay, this background of this research is because the DNA from perpetrator or victim can be left on fast max at crime scenes. However, the mtDNA degrades over time due to the environmental factor affecting its quality and purity. So understanding the impact of storage duration is crucial for improving forensic analysis and DNA profiling accuracy in a real forensic case. Okay, the method, we analyze the effect of storage duration in quantity and purity of mtDNA on hypervariable region 1 and hypervariable region 2. This method is doing by the DNA isolation and then DNA quantification to measure the quantity and purity. And then after that, we do the PCR, polymerization chain reaction, and then we do the DNA visualization for hypervariable region 1 and region 2. Okay, you can see from the chart, from this chart, that the highest DNA concentration was on the day 1, and then the lowest is on the day 2. And then the DNA purity was also highest on the day 1 and lowest at the day 20. And then based on this chart, you can see there's a really, it decreased significantly rapidly on day 20. And then the visualization of HV1, locus HV1 and locus HV2, we can see that in the PCR visualization of HV1 and HV2 loci in max sample over different storage duration, a faint band for HV1 was detected only in the day 1 sample, while HV2 appeared in several samples up to day 14, but were absent on day 20. So the conclusion that this storage time significantly impact on the DNA quantity and purity on max. The highest level were found on the day 1 and declined sharply by day 20. And then we disclaim that this study is the first as a pilot research to evaluate the quality and purity of mtDNA on the fast max with specific locus, which is really important in forensic molecular research. Thank you.
Test. Okay, so thank you for such a great presentation. So I would like to ask a question. So the marks were claimed to be stored at the outer, okay? But the authors, but you didn't provide precise control or measurement of temperature, UV index, humidity across the 20 days. How can we trust the same of the degradation of DNA was time, but not with environment? Thank you.
Yeah, okay. Our samples, we're talking about the temperature, yeah. In this research, we use the 26 Celsius or room temperature. So this, the homogen the sample, and we collect to cutting the mesh for the next step, like DNA extraction.
So how do you maintain the humidity and the UV index that may be a confounding factor when you start outdoor? Thank you.
Okay, actually we use the same storage, same storage, the storage condition. So we do not, we only observe about the time storage, not the storage condition. So all of the sample save at the same condition of storage, degree, humidity, and temperature, humidity, and
Yeah, and we use that room temperature and not include like a humidity because real case, yeah.
Okay, so my question is, considering that from the poster that it says that it's purposive random sampling, if I'm not mistaken, what what is the inclusion criteria, and why again is it only 6 samples itself? Because I don't feel like it's representative.
okay,
enough.
actually we take sample from 6%, but the max will cut off into 4 pieces, 4 part. So we divide it at the day 1, day 7, and 14 and 20. So there's 24 sample. So why we choose this sample size? Because on the previous study, who did the same analysis using different sample, is also pilot at the first time using only 6 repetition.
Okay. About the low copy number, it says that on your poster, it says that from Butler 2010, it states that if below 0.1, then the amplification is regardless of the storage be yield a failure. So did you in your paper did you test it, and is it that low? Because like if it's low, then that means that the research is still void. Low copy number itu kan berarti dia kan kalau di bawah 0,1 berarti kan dia yang juga di situ kan berarti failure. Apakah di sini dites tidak untuk low copy number, apakah dia di 0,1 di bawah 0,1?
Yeah, okay. In this research, we use the mtDNA and we collect the DNA and we analyze with hypervariable region because this is the pilot study and because in the previous study we look the DNA analysis with nuclear DNA, and we choose the topic about the how a factor to decrease the DNA. So we choose the research and like that.
Okay, so you also mentioned sweat, saliva, and keratinocyte contribute to the DNA. However, I didn't see however, you did not state clearly whether the participants were talking, exercising, or just breathing. So what is the standards of the participant? I mean, everything could be inconsistent if the activity is different. Thank you.
Okay, so during the to analyzing this gimana tadi yang bicara atau nafas saja. So the participant will gathering into the same room, doing the same activity, just breathing, not talking. So we try to analyze is that the minimal activities such as breathing, we still can collect the mtDNA.
Okay, thank you. So the participants were doing the same thing, and then how do you standard the max control? What type of max did you use, and then how do you handle the contamination of the max? So you store it outdoor. How do you prevent? I mean, contamination when you're handling. Are you using glove or are you using a sterile? You did not mention any protocol of that. Thank you.
Okay, so why we choose the medical max? Because during after pandemic COVID-19 break, there is a commonly used medical max on our society, and then why we only choose 4 hours? Because on the previous study there is examination 2, 4, 7, and 16 hours. The DNA, yeah, kan 1 hour 1 minute belum.
No, if the question is given at the last second,
Oh.
it will be an extended 1 minute. But if you already answer it, it will be counted as time's up. Okay, so give a round of applause to everyone here.
Okay, bergabung ke Ninja.
Congratulations for team 61. Okay, you may raise the lower.
Ya, atas bawah sama aja. Thank you, sir.
Okay. One more match from the upper bracket. Yeah. Okay, so we are going to have one more match before we are taking a break. Wait a minute. So is there any team 28 here? Okay, team 28, you can sit on my left side. And team 12? Are they there? Okay. We are going to wait for the team 12 first. Is it okay? Thank you.
All the background from like genetics, bioinformatics, it was so painful for us to understand it. If we lose after combative with others?
The winners,
If we lose, no, we're asking who lose.
oh, okay.
We still have to compete.
Cynthia? Because we have not lose anymore.
Okay, I'm gonna make sure for the TV perspective. Oh, okay. If you are the losing team, you will compete again.
What's wrong?
It's still not updated in here, so it will be updated after other rooms have
Finish.
announced the
And then if we win, we will
If you
also.
guys win, you also are going to.
There is still.
There's still.
How many?
I guess it's about. If you're winning, it will be one, two, around two more match.
Two more match.
Yes.
To reach the final, to be the winner.
I'm not sure. I guess it will take up to 9 p.m. today.
Yeah. So if we win now, we still have two matches to enter the finals. Which will get 9.
I guess it will be included in the finals.
These two only till final.
Yeah.
Yeah, Allah.
It's a long journey again. So where are you guys coming from?
I am from Yemen. Serbia dari Tanzania.
Oh, okay. But you guys stay in Indonesia?
Yeah,
or?
we are mahasiswa di UNS.
Oh, okay, that's nice.
And you're living in Jakarta?
Where originally from? I'm from Krasno, Sulawesi.
Yeah. I'm from Sulawesi.
Yeah, Unhas, yeah.
Yeah, Unhas.
Unhas anyway. Yeah, I'm from 12 hours from Makassar.
Makassar.
So,
Yeah. I'll come there. Inshallah. So it's so far dari Jakarta, right? It is another island.
It's another island.
Yeah, Sulawesi. You have your own language also.
It's
not
not
Java.
Indonesia. It's not
Yeah.
Japanese.
Yeah, but what is the name of your
Buddhist language.
Yeah.
Oh, that's hard. I also don't know about Buddhist language. I usually just use Indonesian anyway.
I use my data. It has the ethnicity. So like I will call my friends who are Indonesia, come and divide it for me. This one from Java. This one. Buddhist. Yeah, I hate about it.
It's kind of confusing.
Yeah. Do you know Sylvia's team name? I don't know. Do you know them?
What?
Team. This for the TV.
The TV?
Oh.
Team 12.
Yeah, but he's not from our cycle, right? He's from the previous cycle, not from us.
Did you inform them?
Yes, they said they wrote in the group.
You wrote in the group?
Sorry?
Did you call Team 12?
Yeah, I already called. My colleague already called them.
Which name are they? Why I don't see them?
Maybe they are.
Well, from cycle 1.
Because I don't see anywhere.
Hello.
Sylvia, yes, right? There is a mental expert. Yeah, I think yes. Yes.
Do you want to check your presentation first?
Yeah, team 12, right? Yes. Okay. Yeah, yeah. Oh, it's finished. The water is finished. There is water. Yeah, with the cup. With the glass.
Okay, we are going to start the tournament. Team 12, can you be seated on the right side now? Okay, before we start the presentations, the tournament, I'm gonna re-explain about the rules. The defender team will have 3 minutes to present about their studies, and the other team, the attacker one, has 6 minutes to do a question and answer sessions. Within that 6-minute question and answer, the attacker have 30 seconds to deliver their critiques and questions, and the defender have 1 minute to defense about their studies. So before we start, we're going to choose who gonna attack first. The winner will be attack first. Which side do you like to head? Okay, you're going to be the tail. Okay, so the number is winning, so you guys gonna present first. Okay, team 28. Would you like to try the clicker first? Okay. Okay. And I would like to encourage during the presentation and Q&A, please use the microphone always. Okay. And you can start to present now.
Should I stand also? No. Just start now. No, wait. Am I allowed to stand because I can see they're filming?
Boleh.
Okay, good evening, everybody. My colleague and I, Sylvia, we are going to discuss about gender disparities in depressive symptoms and its determinants among youth Indonesia findings from IFLS data. Okay, so mental health is a public health issue that impacts people of all ages, especially in the low and middle income countries. And we have found that WHO predicted that by 2030, depression will be the most prevalent incapacitating illness worldwide. In Indonesia, according to SKI survey, they found that the prevalence of depression was 1.4% in 2023. And in 2024, Indonesia was ranked the 5th country among the Southern East Asia countries with depression, as you can see there. Okay, so our study aimed to examine the determinants of depressive symptoms and among Indonesia youth, focusing on gender differences.
Thank you, Sylvia. So our study is a cross-sectional study. We use IFLS data 5. After we merge the data, descriptive analysis, univariate analysis, and bivariate analysis was conducted. After we remove all the exclusion criteria, 6,522 participants was included during our analysis. This is the scales that we use it for the depressive symptoms. This table 1 explains how is the descriptives and univariate analysis was conducted. As we can see here, female is slightly higher than the male. Multivariate analysis explains that there will be a similar factor between male and female, which is being unmarried, and none from Java and Bali who reported unhealthy, for who are former smoker, and lastly who are unsatisfied with their life. However, those who are smoking currently is only factors affecting male, and those who are having one comorbidity or more than two comorbidity is affecting female. So we conclude that depressive symptoms are common among both male and female. The factor contributing to the depressive differ by gender, indicating the need for the gender-sensitive mental health strategy. So for the male, we recommend that anti-smoking camp, youth-oriented service such as vocational training center, sport clubs, and workplace. And then for the female, agriculture integrates mental health care into chronic disease management. And in generally, we recommended that mental health should be increased the awareness, especially in the school. They should to teach the students how to do diagnosis, to know, like, because depressive, no one can diagnose it, right? If you get that disease. So it should be in the curriculums of the school. Thank you.
Thank you very much for the presentations. We are going to reset the timer for 6 minutes first.
All right, so 6,522 youth are included for as the study population, but you did not specify what are the inclusion parameter that you are using for this study. So can you please explain to us what's the inclusion parameter?
So inclusion criteria was youth between 15 till 24, who doesn't have reported any psychological disease, and also who has complete data analysis for all the variables that we use it in our study.
Okay, thank you. I fail to understand how you gather data or merge the data. You say that you have AFLS 5, and it's like actually like 10 years ago, and why you still use this data? I think it's like it's too old if it's 2025 now. And also, how would you merge it with the CSD scale? I don't really understand. You have two set of data and then you merge it, or it's included in the AFLS?
Okay, so in IFLS data, we have the link. When you download that, in that link, you will find the data set in all variables. For example, social demographic, health, something related to the children. It depends on the category. So by using this data, we use the command of merging data. For example, I need social demographic, social economic. So I use it by data and I merge the data. This is the first question. And then the second question, why I use IFLS data, even though it is old. You know, after COVID-19's crisis, there is a shifted, right, from especially in the mental health. So our data, we can use it as a baseline to compare the study before COVID-19 and after COVID-19. And then the second reason is that we found a study in 2022. They showed similarity to our study before, which is the determinant is already constant, like being unmarried, employment, it affected during the COVID. You want to
And
Okay, I have another question. Why you use Java and Bali as your reference? Why not other sites?
Because that is what we got from the IFLS data. In IFLS data, there are specific provinces that were merged in IFLS data. So we have to use those specific provinces to conduct our research.
According to the SKI in 2023, the highest province is Yogyakarta and then Java and Bali. So we merge Java and Bali and Yogyakarta as a win, and then non-Java and Bali as one side. Why? Because the economic and then the urbanization in both Java and Bali are similar. Right?
Okay, I understand. Why don't you just make it more specific to the region instead of the whole island like Java and Bali? I think it could be more specific.
We found when we start to do the analysis, some of the province they have only 1 and 2, and it affects our analysis and the power of the statistical. That way, and our study is like in general to determine it. If I will do by the ethnicity, so I can divide it.
Okay, I have another questions about the covariate. Can you just please show me the multivariable analysis? Okay, this. You showed all of the set of the data of variables you have from the IFLS, right?
Yeah.
And my question is, did you try to eliminate or drop out the covariate? So because I see that some of them like unemployment, there's not some statistical not significant and you still attach here. Why don't you just drop out and you have the final models with the more significance?
Yeah, so some of the studies, they already show that there is an association, right?
Yes.
So we already choose our variable from the literature review. It is non-significant in our study. However, it is significant in another study. That's why we select this variable.
Yes, I understand, but still, you are the one who do this analysis. You can just make and our final decisions by yourselves, which is you can maintain or which can you drop out it from the models.
Yeah, thank you so much. This was just to describe for you whatever we did and we showed it, but in the conclusion we have specified and told you well and explained very well which factors, which variables were associated and which were not associated.
And our research question is that to see what is the determinant between males and the females, so I can finalize it and conclude it.
All right. CSDS, I've seen the scoring matrix. It is very subjective. And how do you ensure that the participants who answered the CSDS, it's not a pseudo-depressive, because there's a tendency where adolescents, they tend to have a pseudo-depression. How do you guarantee that this does not have an effect on a bias on your data?
Yeah, we have two things. We have a question about psychological disease, if you have diagnosed before or not.
Right.
So we exclude all these who are reported with a psychological disease. The second thing is before they conduct IFLS data, the reviewer take a very big training, so they are able to conduct these questionnaires with the people. And the third thing is that this CES is one of the golden surveys that is used, valid and reliable, especially even in Indonesia. They use it to see the sensitive and the specific, and it was 80 till 70%.
All right, then also the IFLS 5 is a bit outdated. Why don't you use Indonesian National Adolescent Health Mental Survey?
Yeah, because of the factors that we stated before. First of all, we told you that it has large comprehensive of data, and it covers 80% of the population of Indonesia. And also it uses SES, which has been qualified that it has the varied scale of using IFLS data. Also, the variables that are found in other studies are not good.
We can discuss it later.
We'll discuss it outside.
So our study is about spatial, temporal, and risk factors analysis for drug resistance in West Java from 2020 to 2022. As an introduction, TB remains a public health threat for Indonesia, with West Java reporting the highest TB burden. Geospatial studies in TB mapping and risk factor analysis for DRTB that involves large data are still limited in Indonesia. Our data source is from the SITB. With we've obtained 302,000 cases after data cleaning. With here are the epidemiological variables, 9 of them, and then there are the statistical analysis that we use are Poisson regression, QGIS, and R for geospatial analysis. This study design employs a cohort retrospective. As for the result, the temporal trend indicates that TB burden is actually rising. There's a significant dip because of the COVID-19 pandemic. For spatial mapping, you can see all regencies, they are reporting an increase in TB burden, but I would like to highlight that the Bogor area and the Bandung area, they both in the DS and the DRTB, they consistently report high TB burden.
Okay, so this is the first plot of relative risk associated with the occurrence of TB drug-resistant cases. And as you see, that is really high number of risk for people who treated in the after loss to follow-up if we compare to the new patients. And also the people who treated in the secondary healthcare has the higher risk if we compare with people treated in primary healthcare. So most of them we have a significant number because we have a very high set of data. And okay, so this is the global Morans and local Morans index. So the upper one is the global Morans index. It shows that the Morans is up more than 0. It shows that it have positive correlations. So that means the regions with have the surrounded area have also the same high number of cases, which means it's affecting each others. So this is the Bandung, Bogor, and Kota Bekasi. So consistently show that from over years it has in quadrant first. So it's have the high and high. That means that this surrounded or affecting with the other areas with the high number of cases as well. And the conclusions, the number of regency reporting a higher TB burden is increasing from year to year, but there is a little bit of decrease from 2020 to 2021. And the key risk factors for DRTB includes the loss to follow-up, secondary healthcare facilities, and diabetes. But I want to highlight that this is the most high-risk numbers. And also the special analysis that we do is consistent clustering of TB cases in densely populated urban areas such as Bogor, Bandung, and also Bekasi. And the regency reporting high TB burden correlates with clusterings with neighboring regions. Now that means if the region have the high number of TB cases, that affected by other regions with high number of TB cases as well. And the limitation of the study that our limited study period and limited socioeconomic variables were utilized. Thank you.
Okay, thank you for the presentations. We are going to reset the timer first for 6 minutes. And you can start to attack from now.
So thank you very much for the presentation. I want to ask about how did you account for underreporting cases like drug resistance cases by using this database?
First of all, it is impossible to estimate the underreporting of cases because SITB it's a subnational data of passive surveillance data. So you can't estimate underreporting. You can do a mathematical modeling, but that is beyond the scope of our research.
Did you get missing data? How did you treat missing data?
We any data that with our missing variables, we delete them all because we know it's going to be a confounding variable if we include them.
How much did you delete? Will it affect your sample size?
We have a total 330,000 data set. It's a really high number of cases. So the missing data, which is incomplete data, we just delete it, and it doesn't affect with our analysis because it's a number set of data is really high. As you see that our significance is below 0.00 and 1. It's really significant.
Okay, thank you so much. So as we all know and we are aware about the social determinants of health, so how do you account for the impact of community behavior and beliefs on TB transmission and treatment there is using your analysis?
Can you repeat it one more time again?
We have social determinants of health.
Yeah?
You understand? So how do you encounter the impact of community behaviors and beliefs on TB transmission?
All right, so to start with, the Indonesian understanding of health in general is actually really low. there is a survey conducted by the Bureau of Statistics that I don't remember the specific number, but for the areas of West Java, the regions in West Java, they report a low understanding of health knowledge. That's the first part. And then second part, how does community interactions? Bandung, wait, no, sorry, not Bandung, Bogor and Bandung Regency, they only have a GDP per capita of 54,000 to 54,000. 44 to 54,000. So you can expect that they are they come from the low social income household. So of course, we can pull a hypothesis that they will live in areas with poor household situations, like for example, maybe a poor ventilation and then overcrowding.
May you open figure 1? Yes, yes. Not to this one. Yes, here. If you can see here the confidence interval, the employed, it starts 1.43 till 0.23. This cannot happen. Confidence interval, usually the lower limit is down and upper limit is there. Go down. Yes, here, 1.43 till 0.23. How can you explain to me this result? Usually confidence interval start from lower limit to upper limit.
Can you please zoom it? So, yeah.
Here. 1.43 till 0.23.
I'm sorry, I think it's an error from me. I write that down and it's basically my mistake. I'm sorry. Acknowledge that.
So with the reported cases, the increase in TB cases over the years, how do you account for the potential changes of healthcare access in reporting this practice that could influence these trends?
That can influence the trend upward or influence the trend either upward or downward. All right. So first of all, to start, I would like to point out that this data is from 2020. The latest year is 2020, the end of the period. Indonesia only recently began implementing Gene Expert in 2023. Now, because of the expectation is because since Indonesia implemented Gene Expert for TB diagnostic, we can assume that TB reporting will continue to increase. Why? Because it means better surveillance methods.
So my question is
Yes.
that how will you deal with these trends? Because you're studying about TB, right?
Yeah.
So how will you deal with these trends? Because we see you said that TB is increasing.
All right. So you want a
study,
translatable solution. Okay. The solution is that we've identified the social determinants, and then from that social determinants, we can better design an intervention package that is more suited or more adjusted towards low-income households. And for example, I would also like to point out that a lot of the community health centers in West Java, their capacity for gene expert diagnosis is still quite low because Indonesia only have make a standard parameter of for every one community health centers that can do gene expert, there should the ratio is 1 to 5. So for every 5 non-gene expert, there's only 1 gene expert.
So I want to know about the PCG vaccination that
Yeah.
is coverage in West Java Central with TB incidence. Can you tell me about the PCG vaccinations?
BCG vaccination.
Yeah.
So there's no data in SITB.
So there is no data.
There's no data.
What about the BMI? Because nutrition is
But
one
you
of
must
the
know
risk
there's no
factors.
data also.
Also, there is no data about that.
No.
Okay, and then how effective did you find that the use of the globals and the locals, Maroon, the analysis that you use it to understand spatials in TB cases?
It just simply said that the area with the high number of risk surrounded by the high number of risk cases as well.
And then how might interventions differ from the drug sensitive to drug resistance TB in terms of the healthcare resistance allocation?
How
treated TB drug resistant and sensitive?
the treatment. The difference. All right. So for the difference between DSTB and the RTB, first for DSTB, the idea is to prevent them from being a drug-resistant case, and for drug-resistant case, the idea is to prevent drug resistance from transmitting further. Now, what is the intervention package? If I have to choose, first we need to do social economic support because a lot of TB patients who begin their treatment they lost their job, and their source of income also diminished, right? And their chance for for dropping out of their treatment will significantly increase. There is a study by Van den Hoff that have estimated where it is around, I think, $150 per person that's the cost of indirect treatment, only like vehicles, food consumption. So maybe the government, they can start preparing, maybe they start chartering ambulance.
Because it's a draw, we are going to have an extension for 4 minutes. So each team will have 2 minutes to defend their studies, and the other one can ask questions for 2 minutes. Maybe we can reset the timer first.
Wait, so we can start?
Wait a minute. Nafas, minum dulu.
So you can, they will start first. Ask about your study. You have 2 minutes for question and answer, and it starts now.
Okay, please, can I go to your results part? I don't know if you mentioned this, but I know that what you used, either there was secondary health care and primary health care, right? Yeah. So relative ratio, what was the relative ratio between the secondary and primary? Was it high in secondary or in the primary?
So we are using the Poisson regressions here, right? So we are having a risk ratio rather than odds ratio. And with this, we have the reference. The reference is primary health cares.
The primary health cares?
Yes.
And we saw that in the primary health care, it is low or high?
It's lower. The secondary health care is 21 times higher risk than the people who treated in primary health cares.
So it means that either, how can you compare this? Because what we know that if what you say is true, meaning there was inadequate resources in secondary data, and also, or maybe there was patient selection bias.
No.
Because it should be vice versa.
No, I think you misunderstood the interpretation. The idea of the interpretation is that because patients report there is a higher risk of DRTB in secondary healthcare facilities. So the idea is that the government should expand healthcare, TB treatment, TB treatment in primary healthcare centers, because all drug-resistant cases, they are referred to secondary healthcare.
Yeah, but I asked about the relative ratio.
The relative.
Yeah, the relative ratio. It's yeah.
Yeah, they are
meaning if they are high in secondary, there was either patient biasness, what was conducted, or there's inadequate secondary health care.
No, it's because the people who treated in their TB used to refer to the secondary healthcare. That's why this number much higher than primary healthcare.
What about selection bias?
There's no selection bias. So we have several types or more detail here, but we merge this secondary and primary.
Okay. Why do you?
Wait, because the data all the RTB patients, they in SITB they will be referred to hospitals. So we can't do selection bias. It's already naturally in the data itself. Yeah, sure. Why not?
Okay, first I want to criticize actually for your graphs. I'm sorry, can you just, here, yeah, here, oh, sorry, yeah, this, the error, you supposed not to say it's, it is like you add additions this number to these tables. It's supposed to be you have the arrow out of the tables. And the first, it's just my criticize for these tables. And the next my questions is that why in famous low social participation is protective factors? Do you have any journals that you find?
Why what?
That you find it's how to support your research?
No, what?
What is the question?
The participations is protective factors for females.
Yeah, social participation is interestingly factors that we found in our study. So we interpreted that maybe this woman's, the women usually when they go for the social participation in the Indonesian context, we can say, maybe she already have her own responsibilities. So when she go also to do the social participation, it will increase her responsibilities. Then it will increase her stress. And stress is one of the factors that mediate the depressive symptoms. So you got your answer?
All right. Then after that, one thing that I noticed from IFLS is that they do not have a variable that measures the household dynamic. What does a household dynamic? I mean, is by a relation between their parent, for example, parent and then their friends. While the Indonesian national adolescent, they have that variable. And I've read also several articles that says that variables, household dynamic is more significant, is a significant factor. And I think that by you not including this, you
My outcome is depressive symptoms. So may you give me any data that use depressive symptoms? SKI, it use also depressive symptoms. So many of the secondary data they don't use. I search in the DHS, in SKI, but
Okay, let's give a round of applause for congratulations for the 28 for finishing the session. Okay, everyone, we can take a 30-minute break, and after that we can continue the.
Okay, no?
thank you very much.
You're welcome.
Huh?
Nanti diupdate ya dok.
Oke,
Masih
ya.
lama soalnya. Thank you. Ya udah, coba kita tanya dulu ya. Tegang deh. Orang yang berantem juga handphonenya heboh. Udah biasa Iya, astagfirullahaladzim. Gimana lu?
berjam-jam lah.
Yang gue bilang ke Kaya soal kita butuh intern tuh gue gak bercanda, gue tuh serius. Kayak kita itu butuh intern, gak intern yang spesifik satu gitu, internnya kalau sekarang umumnya konten kreator di intern moderator
Team 4 is every member of the team is here already. You can take the seat on my right side. Okay, everyone's here. How are everyone's doing right now? Tired, yeah? Okay, that's okay, a little bit more. Okay, before we start today's match, I'm gonna re-explain about the rules again. The defender team will have 3 minutes to present about their presentations, and the other team will have 6 minute question and answer. During that 6 minute question and answer, the attacker have 30 seconds to ask or critique, and the defender team have 1 minute to answer or response to the critics. Before we start, we are going to choose who gonna be the attacker first. The winner will be the attacker first. And which side of the coin will you choose? Head. Okay, you guys are going to be the tail. Sorry. I'm so sorry. Yeah, I'm a little bit excited. Okay, so the head team wins. So you guys are going to defend first, and we have 3 minutes to defend for the team 4. Would you like to try the clicker first? Okay, it works. Okay, and your 3 minute presentation start from now.
Yeah. The title of our study is Cognitive and Behavioral Comorbidities in Children with Chronic Epilepsy. I think the timer is not. Epilepsy is a chronic neurological condition that contributes to a significant disease burden in children and adults worldwide. There are so many epilepsy syndrome. One of them is chronic epilepsy, also known as self-limited epilepsy with centrotemporal spikes, which accounts for 10 to 15% of pediatric epilepsy cases. Although it is called self-limited and benign in clinical course, an estimated 15 to 30% of children with SELECT experience cognitive and behavioral impairment. The objective of our study is to examine cognitive and behavioral comorbidities in children with chronic epilepsy. It was a cross-sectional study done in 9 locations in Jakarta in 2020, and the inclusion criteria was children aged 6 to 12 years old with chronic epilepsy based on clinical manifestations and EEG findings. We had the total of 34 subjects, and all the EEGs were reviewed by senior consultant in pediatric neurology, and the assessment of ASD or ADHD using the SM5 and the IQ testing was done by a psychologist. And the result was the majority experienced seizure onset between 6 to 12 years old, and the predominant source of epileptiform waves are in right hemisphere. And we found no statistically significant relationship between the age of seizure onset and cognitive and behavior comorbidities. And we've also found no statistically significant relationship between the number of brain hemisphere and cognitive or behavioral comorbidities. Although Rolandic epilepsy is mostly considered as self-limiting and benign in its natural course, but some patients still have unignorable cognitive and behavioral comorbidities, and the relationships within variables in this research are not statistically significant, but physicians are still necessary to monitor cognitive and behavior comorbidities during epilepsy treatment. Thank you.
Okay, thank you for the presentations. We are going to reset the timer to 6 minutes.
All right, thank you for the presentation. So I see that your study only involved 34 sample, and I think it is so small. So I'm afraid that your finding can be lack of significance.
We have done calculation of the sample size, and Rolandic epilepsy is quite rare. So the 34 is the minimal sample size, and it's based on the calculation.
What kind of calculation and what is the justification? Because I have read Journal of Wickens et al. 2017 that it is a meta-analysis of epilepsy, and mostly it includes at least 50 participants. So can you provide any justification for the calculation?
There are about hundreds of epilepsy syndrome. Rolandic epilepsy is one of the epilepsy syndrome, and not many patients with Rolandic epilepsy. So we cannot extrapolate between a single syndrome and epilepsy in a whole.
All right. Move forward. Your study group ASD and HDHD to single variable, because I think it has distinct condition with different criteria and profile. So why do you group it in single group?
There are three reasons. The first is there are similarities between symptoms of ASD and ADHD. And the second is the pathophysiology. There are similarities in pathophysiology between ASD and ADHD, especially in neurons firing the brain hemisphere. And the third is we found a very few subjects with ASD and ADHD, so we put it in one variable to make us easy to do the analysis.
But why don't you just analyze it separately? Because based on the DSM-5, it explicitly classify ASD and HDHD as different disorder. So I think by merging this disorder into one variable, it might weaken the clarity and the clinical utility of that.
Yeah, you're right that the definition of ASD is different from ADHD. They are two distinct diseases, but we only found one subject with ASD and less than 10 subjects with ADHD. So with the reasons that I've mentioned before, in the analysis, we put it in one group. But if in the future studies we found more subjects, maybe we can break it into two distinct variables.
So I just want to add more. So the outcome of interest is actually behavior problems, and it comprises of ASD, HDHD, and then ASD and HDHD. So that's what the outcome of interest.
Sorry, but you said that the sample of HDHD is like 10.
There are 34 subjects with Rolandic epilepsy, and we found only less than half of all the subjects had behavioral comorbidities like ASD and ADHD.
so it is less more smaller number of sample, right? I think it can increase the bias of it.
Um, what we describe is the description of behavioral comorbidities and cognitive comorbidities in Rolandic epilepsy. So, all subjects with Rolandic epilepsy, most of them don't have behavioral comorbidities. Only few have behavioral comorbidities. So, we put it in subject of Rolandic epilepsy, not behavioral comorbidities only.
Okay, next question is, I guess in the limitation for the cognitive testing, right? Why did the study only assess the verbal IQ using the four subtests? What about other cognitive domains commonly affected in the epilepsy? Because it's really solely the verbal IQ is the misses other vital cognitive functions.
There are three subsets of IQ: full scale, verbal IQ, and performance IQ. But specifically related to and ADHD is the verbal IQ. So I put it in my slide. But we also obtained the performance IQ result, but I didn't put it in the slide.
Okay, but I see in your slide and your poster that you claims you want to assess cognitive outcomes. Meanwhile, you only use IQ domain. But there is multidimensional of cognitive outcome, right? Like working memory, processing speed, and etc. So I'm afraid it may misleading the conclusion of yours.
Yeah, in previous studies, the most used test for cognitive is IQ. Why? Because it is very objective. It is mentioned by numbers. So I think because the power of its objectivity, many subjects, most research use IQ test for evaluating cognitive issues.
And I mentioned you not not included the medication effect and not consider it, and also in anti drugs and influence in cognitive and the behavior. Why were the medication type of effect control or reported?
Okay. Yeah, we didn't mention about the side effect of anti-epileptic drugs because that is not the objective of our study.
Alright, good afternoon everyone. My name is Indira with my friend Rizal. We want to share about our research optimization of peptide-based drug design targeting reverse transcriptase HIV using QSAR integrated with machine learning and quantum mechanics. So, despite the advancement of HIV treatment, there is research that show more than 30% of patients have missed ARV to avoid the side effect. And this is worrying because it may lead to drug resistance. Therefore, we need new and better therapies. Peptide-based drugs could provide solution for this because they are more specific, lower side effect, and less likely to develop resistance. Reverse transcriptase is the most effective drug target for HIV because it doesn't exist in human cells, so targeting HIV reverse transcriptase can increase specificity of drug. Therefore, our study aims to design peptide-based drugs targeting HIV reverse transcriptase with optimization using QSAR, machine learning, and quantum mechanics. So this is our method. First of all, we build machine learning model from database of compounds from DUT, and it comprises of 2D descriptor, 3D descriptor, chemical fingerprint, interaction fingerprint, and it was used to train machine learning model. And then we evaluate the models, and we choose the best model machine learning to screen more than 2,003 peptides library. And we choose the top 5 peptides to do MMG-based rescoring. Then we further verified using the FT assessment and molecular dynamic to select the most potential peptide. And this is our result. So from several machine learning models that we have trained, we choose random forest because it achieved the highest accuracy, more than 90%. Then from the top 5 peptides that we choose, we do MMG-based array scoring, and it showed that the NHY peptide exhibit the most negative binding energy, even compared to the drug nevirapine, and it indicates the strongest interaction with HIV reverse transcriptase. And this result is supported with docking analysis, which show NHY share similar residue of interaction with nevirapine. And it also support with the FT assessment, which show NHY peptide has energy gap between efavirenz and nevirapine, and it indicates higher reactivity and more stable. So this study highlights NHY as a promising peptide inhibitor of HIV reverse transcriptase, but however, these findings are limited to in silico prediction and require experimental validation to confirm the NHY efficacy and safety in a biological context. I think that's all from us. Thank you.
Thank you for the presentations. We are going to set the timer to 6 minutes first.
Okay, thank you for the presentation. So as you mentioned before that a peptide-based drug is a promising drugs, right? But what is the information out there? What is the current knowledge, and what is the research gap, and what can be answered from your study?
Yes, the research gap I already told in the background. So there are research that show there are many patients that miss ARV to avoid the side effect of ARV. And meanwhile, in another journal, it showed that peptide-based drug has more specific, so it can lower the side effects. So this is the gap that we want to answer.
Okay. So do you perform external validation for your models with other data?
Like a biological, like in vitro or in vivo?
Yes.
Not yet, because this is a foundational computational study, but in our model we use a database of compound from DUT, which comprise of experimental data. So it is already data that has been experimental in lab.
Okay. Do you perform toxicity profile for the peptide-based model?
Yes, we perform the statics toxicity. Okay. Okay, this one is toxicity prediction. If you see the three best top of peptide and HE, AKT, HES is untoxic, absolutely, and we have the range of the Lipinski rule of 5, yeah, under the 500s. Dalton it's meaning that the peptide have the high bioavailability, and yeah, same like the commercial drug.
Okay, so in clinical setting, we usually use multiple combination drugs. So do you perform like a comparison between the peptide drugs and the combination drugs as your control?
Yeah, so yeah, we did compare it between our peptide with the control nevirapine drug, which is also a available drug that target the reverse transcriptase HIV, and it not only in this MMG-based array scoring, but also in the FT assessment and also in the molecular dynamic. And so yeah, this all of these results support each other.
One of the reason of drug resistance in antiretroviral drug is only using less than 3 combination of a drug. You study only one drug comparing with 2 other drugs, not combination of NHY and the other drugs. How can you assure us it will be less resistant to drug in the future than all previous drug like efavirenz and nifedipine?
Yes. So I want to remind that this is the foundational computational study, which our goal is to narrow down thousand of peptides, to the promising one for the reverse transcriptase. For the another target, for example, integrase or in the N3 protein, we might do it again, but it's in the next step. We want to focus on the reverse transcriptase first because it is the most effective drug target for HIV.
And also, this previous study said the NRT receptor or NRT enzyme is less mutation compared to the another target in HIV, such as the GP10, maybe in the integrase and protease.
You use machine learning and quantum mechanics
Okay,
for the study.
Mm-mm.
How can you make us sure that these methods are more appropriate for peptide-based drug design than others?
Because, okay, wait.
All right. So yeah, because there are already many methods that that show the application of machine learning to drug discovery, and why does it matters? Because if we skip the in silico process first and we directly do in vitro validation, it may require more expensive resource, and yeah, that's why this is important.
Another question. What is the practical impact of your study for HIV drug development? Because the previous drug, the combination of previous drug, has already gave success in treating many patients and reducing morbidity and mortality in HIV. What is the novelty and what can the advantage you can offer more?
Yes, as I said before, in the background there are so many patients that avoid the side effect of ARV. Even they miss the consumption of ARV. That's why we want to try another solution or another alternative. Why don't we use peptide-based drugs? And that's why we want to optimize the drug design of peptide-based drugs.
Last question. Can we see the expectation of the effect of interaction models between the peptide and the reverse transferase? So whether it's can we know
because
whether it will be inhibit or
we know this peptide can inhibit the reverse transcriptase for the list of the interaction. This interaction is conserved to the drug in that the inhibit before.
Okay, everybody, let's give a round of applause for everyone here. Congratulations for Team 4 for winning this cycle, and congratulations also for Team 88 for surviving this part. Okay, you guys might take a break or go to another. Okay, team 12 can sit on the left side and team 4 can sit on the right side. Udah telat banget. Ya udah boleh, 5 menit ya tapi. Oke. Okay, for both team, please sit on the designated place. Team 12 on the left side and team 4 on the right side. Okay, Masnya boleh. Okay guys, I guess you already know the rules. 3 minutes to present your study and 6 minutes for question and answer, 30 seconds to attack and 1 minute to defense. And I guess to decide who gonna go first, let's do rock, paper, scissors instead of coin toss. And the winner will be the attacker. Okay. Okay, so this team will be the attacker, and you can present your presentations. Team 12. Okay.
All right, so our study will be about spatial temporal and risk factors analysis for drug resistance in West Java from 2020 to 2022. As an introduction, TB remains a public health threat for Indonesia, with West Java reporting the highest TB burden until the study period. And geospatial studies in TB and risk factors analysis for DRTB that involves large data are still limited in Indonesia. Our data source are obtained from the SITB with 302,000 data after data cleaning, and then there are 9 epidemiological variables. With our statistical analysis, we use data for Poisson regression, QGIS, and R for geospatial analysis, and our study design is cohort retrospective. For the temporal result, we have obtained that it shows an upward trend by the end of the study period. However, I would like to mention there's a dip because of the COVID-19 pandemic. And then this is the spatial mapping. As you can see that all regencies are reporting an increase in TB burden. And after for both cases, the S and the R, with concentration in the Bandung and Bogor area.
Okay, so here is the first plot for relative risk association with the occurrence of TB drug-resistant cases. Here is quite clear that the number of risk for people treated after the loss to follow-up has the higher risk to get their TB if we compare to the people who new treated, and also the people who treated the secondary healthcare has the higher numbers than the risk than people who treated in primary healthcare. Basically, all of this mostly have a significant p-value. Okay, this is the global Moran's index and local Moran's index. The above one is the global Moran. It shows that the Moran's is up above 0. That means that they have a positive correlations in the global Morans. That means the regions that surrounded by the regions has the highest. The region with the high number of TB cases are surrounded by regions to have the high number of TB cases. And this is we can see that Kota Bekasi, Bandung, Bogor, and mostly Bogor has quite constantly have the numbers in the first the first clusters here that is surrounded by the near area that has a high number of cases. And for the conclusions that the number of regencies reporting the higher TB burden is increasing from year to year, and the key risk factors for their TB, actually all of the risks that we are trying to assess has a significant p-value, but the loss to follow-up, secondary healthcare facilities, and diabetes have the highest number of risk. And also the special analysis shows that consistently clustering of TB cases in densely populated urban areas such as Bogor, Bandung, and also Bekasi. And the regencies reporting high TB burden correlated with clustering with neighboring regions. And the limitation of the study that there are limited study period and limited socioeconomic variables were utilized.
Thank you. I think there are more limitations that you haven't mentioned in your study. The first is SETB mostly used in only public hospital and puskesmas, while there are so many private sectors like clinics and private hospital, they don't use SITB. How can you assure us that the data from SITB is a valid one? There are many patients that we cannot capture only by using SETB.
Okay, thank you for the question. We actually can see the result of the correlations by the risk ratio. It shows that mostly we have the significant p-value below 0.001. So we can say that is significantly.
No, I think that you don't answer the question.
All right, so I would like to ask that actually most cases, they are captured through public government instances. That's the first. And then for the supporting argument is that this hospital, as you can see, that the risk factor is on secondary healthcare facilities. And yes, and these are government hospitals. That's an argument. And then do I think that it can have an effect on skewing on underreporting? I don't think so, because probably the difference is only going to be only like 5% at max, because 95% of the cases they will be recorded they will go to a public health facility because they receive free treatment. That's it.
Because in my experience as a clinician, that's not the fact. I work in public hospital and I know the private sectors. I think more than 5% is not recorded in the SETB. Okay. The second is I like to add the limitation of your study is the use of TCM, test cepat molekuler, gene expert. Drug-resistant TB, we can only found if the patient is obtained the sputum and use the gene expert. Well, still many patients don't use PCR.
Okay, so first of all, that is a variable that is beyond our control. And then second, to correct your statement, Indonesia only began implemented gene expert on 2023 because the national guideline just came out on 2023. The majority of cases, now they begin implementing gene expert. So I would say most of these cases are actually diagnosed through sputum culture. That's the first one. Second, as I stated before, that is a variable that is beyond our control because it's a government policy. I mean, yeah, sure, the government already began implementing a gene expert, but I would like to highlight that, sure, PCR is more sensitive. It's correct. Maybe it can detect a lower threshold, sure, but PCR is more expensive. We don't have the capacity because we need to train, we need to set up special laboratories, and then after that we need to set up a new primer, and then I would say that's why gene expert is a more viable option instead of PCR.
Yeah, Gene Expert use the same method and it's free. You don't have to spend any money for Gene Expert test.
So you mentioned that there is a significant risk factors there. But did you make a geographical analysis on that risk factors that which is significant? Yeah.
Oh, so this for overall, so global morons.
This one, the significant, very skewed one.
Yes.
The secondary facilities. So did you make a geographical analysis, like which part of the West Java?
Oh, not yet. Not yet. We don't.
Not yet, but I would like to add that despite we don't taken into consideration of the risk factors, I would say that the result that we've obtained, it actually correlates with the risk factors, because first of all, the diabetes is actually a the percentage of diabetes, I think, is around, I can't say the perfect number, but it is a problem, and the DM have an effect on TB resistance. That's first. And then second, hospitals, people here, especially in like as Bandung and Kota Bekasi, it is an urban area, and they have access, they have easy access to hospital. So that's why you can see that the risk ratio is it's concentrated in secondary healthcare facilities.
Do you consider that maybe the area that is not in urban area is actually under diagnosis for the TB resistance?
It could be. It could be. It's a possibility, but once again, we can't control the variable because it comes down to government policy and the capacity for community health centers within the context of this study period. The government only force a ratio of 1 to 5. So for every 5 community health centers, there should be 1 community health centers that can do gene expert at that context.
Can you assure us that your study can give a good policy, because your sample is obtained in Bogor, Bandung, and Bekasi. Those are cities who the persons may not live there. Maybe they live in Jakarta or in surrounding Bandung. So I think you should add this to your limitation of the study.
No, I have to disagree with that, because we have stratified the data by where is their domicile, not where do they receive the treatment. Because when we do the data cleaning, we found out there are several patients who actually live in Jakarta or surrounding area, but they choose to go to, for example, to Bandung or Bekasi. That's the first part. And then the second part, we can translate it. What's the translatable applicability is that first, patients with low income, they need to receive support from the government in the terms of indirect costs.
Okay, time's up. We will have 1 minute left before we move to team for presentations.
Thank you. We'd like to present our study titled Cognitive and Behavioral Comorbidities in Children with Chronic Epilepsy. Epilepsy is a chronic neurological condition that contributes to a significant disease burden in children and adolescents worldwide. There are so many epilepsy syndromes. One of them is Rolandic epilepsy, also known as self-limited epilepsy with centrotemporal spikes, which accounts for 10 to 15% of pediatric epilepsy cases. Although it is called self-limited and benign in clinical course, an estimated 15 to 30% of children with SLEX experience cognitive and behavioral impairment. The objective of our study is to examine cognitive and behavioral comorbidities in children with Rolandic epilepsy. It was cross-sectional study, and we done in 9 locations in 2020. We include children aged 6 to 12 years old with Rolandic epilepsy based on clinical manifestations and EEG findings. We obtained 34 subjects, and all the EEGs were reviewed by senior consultant, the pediatric neurologist, and also the assessment of ASD or ADHD using the SM5, and the IQ testing was conducted by a psychologist, and the result was most subjects experience seizure onset between 6 to 12 years old, and the predominant source of epileptiform waves are in right brain hemisphere, and there was no statistically significant relationship between the age of seizure onset and cognitive and behavioral comorbidities. And there was also no statistically significant relationship between the number of hemispheres and the cognitive and behavioral comorbidities. Although Rolandic epilepsy is mostly considered as self-limiting and benign in nature course, but some patients still have unignorable cognitive and behavioral comorbidities. And the relationships between variables in this research are not statistically significant, but physicians are still necessary to monitor cognitive and behavioral comorbidities during epilepsy treatment. Thank you.
I saw that you use case control study, which is a very unique choice, I would say, because cross-sectional, yes, cross-sectional. With the context of it, you only managed to obtain 39 patients, but why? What's the rationality for you not using case control study when you are looking first from the outcome? You want to see the outcome first.
This is a pilot study that was never done before in Indonesia. There are previous research about Rolandic epilepsy and comorbidities in other countries, but not in Indonesia. So as the first study, the cross-sectional method, I think is the most appropriate.
And for the British one, how many patients do that research use? Sorry, the reference that you used before just now. You mentioned the reference. You said it's a pilot study, but based on what reference? Like, what is the population sample that you, yes.
Comparing with other countries, not in Indonesia.
Yes.
Maybe, more than 5 countries.
No, what is the population? Population of the study population.
Yeah,
how
so
many patients do they enrolled into that study?
Okay, so in previous study, usually they started from 50 because around 50 up to, but because the prevalence is quite rare.
All right. Okay, still, but in epidemiological study, even in clinical settings, it should be a case control study. It does not address the temporal ambiguity, and then it also can have an effect on your statistical analysis later. And then I would like to move on to the location of your study. It's not mentioned. Can you please mention to us what is it?
Yeah, there are 9 locations, RSCM, RSUD Pasar Rebo, RS Harapan Kita, Klinik Anak.
All right, okay. And then what are the criteria for choosing those 9 locations? Why are those specific hospitals?
Those locations have pediatric neurologic consultant, the senior ones, because not many child neurologists can diagnose Rolandic epilepsy in the first place. So we need more experienced pediatric neurologists, and those places have the consultant.
Okay. Have you ever tried to? Is it possible for you to increase your to include more study setting, more hospitals out within the greater Jakarta area? But I think you can reach maybe like 12 hospitals to obtain more samples.
Yeah, that's a good advice for us.
Okay.
We actually did a sample size analysis before, sample size calculation, and it's based on the prevalence study. We found we only need 34. So I think this is even though it looks small, but the power to detect the difference is quite okay.
Quite okay, all right. And then another thing about the have you taken into consideration about confounding variable? Did the analysis include patient consuming anti-epileptic drug? did you factor that in your analysis?
In the table, we included the number of anti-epileptic drugs, but we don't analyze this because we didn't try to find the relation in this variable. We only try to find the comorbidities of behavior and cognitive issues only.
Okay, and then can you look at the sample, the population division? Go left. Keep going. I mean, left is like, yeah. Previous slide. Ah, there you go.
Okay.
Look at that. The number of hemispheres, it's like even the age of onset is not evenly distributed. Don't you think this can skew the data and the result? Skew.
Yes, because I don't think that it's where it's skew.
Okay. Why do I include hemisphere? Because logically, if we have more than one focal hemisphere, it will be more devastating than only one. So both hemisphere included is afraid to have more comorbidities than only one hemisphere included. But in the statistical analysis, it is not significantly statistically significant.
No, actually, I'm asking like why, under 6 it's 12, and then above 6 is 21. Like the gap is really different. It's like nine patients, right? I think that can skew the data. But why don't you make it like evenly distributed on both sides? If you say the population,
Oh yeah, because most children who underwent chronic epilepsy start at 6 years old. There are several epilepsy syndromes which start at over than 6 years old and starts from infants.
All right. And then after that, I noticed also there's no control or comparison to other epilepsy. Why? Why do you do that? Isn't it better to do a control?
Yeah, because each epilepsy syndrome is unique, and we cannot compare between one epilepsy syndrome and other epilepsy syndrome. Why do I choose chronic epilepsy? Because it is quite common for rare epilepsy syndrome, and because you cannot say it is only self-limiting and benign. There are still comorbidities. That's why I choose epilepsy chronic other than other syndrome.
All right. I would like to find if the results are insignificant, then what are the added value of this study? Like what are the clinical translations?
Okay. Yeah. Even though it is not statistically significant, but you can, but you can see here there are still numbers that we cannot abaikan. Yeah. There are 13 patients who is the IQ below the average. So we cannot. This.
Yeah, even though it's not statistically significant, but it may still clinically significant because the number you seen there, the IQ below average is 13. So we need to we need to remind about that.
Okay, everyone, let's give a round of applause for and congratulations for Team 4 for winning this round. Okay, so this will be the last match in this room. You guys can join Semeruti for another session. Thank you very much. Sudah selesai. Bisa lanjut di Semeruti atau boleh bantu Sina yang akan
Missing data, we're treating that.
Okay, serious game. Just take a breath and slow down. Okay, 1 minute break.
All right, the now score is still series for team 4 between team 28. Very great debate here. On fire, yes, on fire. So, because the score is series, so we have additional time for 4 minutes left. 2 minutes, the team 4 will be the attacker and you will be the defender. And 2 minutes again, you will be the attacker first, and team 4 will be the defender. Dari koin. All right. All right. To decide who will be the first attacker in additional time. Okay. You choose half or tail. Tail. All right. Tapi yang deg-degan. All right. Okay. Okay, health one. So the health one will be the first attacker. Okay, let's prepare for 2 minutes first. You will be the first attacker for this session. 2 minutes.
So, what statistical tests were you used to assess the associations between comorbidity seizures onset?
For the normality data, we use a chi-square, but because it's the comparison between two categorical data. But for
non-normal tests.
Yeah, normal tests, we use Fisher data. Fisher test.
Okay, and also in your study, you didn't mention the controlling factors like drug use, right? So, how might this emission impact your study, your validity of your conclusion?
It is the use of anti-epileptic drug. We found that some patients have one epileptic drug and the other have more than one epileptic drug. In natural, if patients have more than one epileptic drug, we can predict that the symptoms are more severe than only one epileptic drug.
So you category the age less than 6 and more than 6. Yeah, given non-linear tragedy.
Okay, sorry. Because in chronic epilepsy, most patients are aged over than 6 years old. Only very few less than 6 years old, because the natural course of chronic epilepsy is between 6 to 14 years old.
What about the seizure? At which age?
Usually start at 6 years old. Usually in chronic epilepsy.
Yeah. Okay, I wanted to add on. You guys did the data collection from Jan to September 2020. So it was during COVID-19. The disruption and the access to healthcare, it was very different. How did it impact to your conclusion?
Yeah, the patients still have chance to go to hospital and clinic during the pandemic because they still need to continue anti-epileptic drug continuously. If they don't get the drug, they will get seizure. So some patients, they may go to the hospital only by parents, not by the children. They sometimes don't bring the children to the hospital in the pandemic area. At least they can get the drug continuously.
So can you mention the inclusion criteria and exclusion criteria and why the reason behind that?
And then exclusion criteria, we exclude those who have psychological disease, so to cannot interact with our results. And also missing data, we have excluded that.
What do you mean by the have a problem with the psychosocial?
Psychological disease, yeah.
Because the depression itself is a psychological entity, right? And it's often combined with other symptoms like anxiety and so on. So
In IFLS data, there is a question which is self-reported. Do you diagnose with a psychological disease? So those who answer with yes, we exclude them. So we should to have a filtered data with the depressive symptoms.
So what is the potential bias or confounding that you haven't been encountered?
The most important things is that psychological things, especially cognitive factors, stress factor, which are a mediated factor that is play an important role. But because it is unmeasurable, we cannot find this data in IFLS data, and it is recommended for our study that to conclude in the future, psychological variables should be included, and qualitative research also. It will be valuable to increase this research.
Okay. So in your title is wants to know the gender-based analysis. So I'm just wondering, do you make a consideration about the gender inequality, like opportunity in Indonesia and so on? That's why.
Yes, we did that, and we saw that most of the women that we found that they have slightly recognition with depression, all of them were, we had the women who had maybe smokers, the men were more, and comorbidity or two more comorbidity were from the female. So after knowing that, we anticipated what should be done to the female and what should be done to the male.
Time is up.
All right, again, give it up for this very great match. And congratulations. So, the winner of Shinjitsu Grand Tournament is Team 28. All right. Okay. Congratulations. Maybe there is, you want to, just one feedback from judges? Okay.
Wow, I'm speechless. Just fantastic. I'm breathless. Amazing match. Just incredible. Wow. So I have to say, I think what was beautiful about that match is that you were each challenging really key things that were a weakness in the study, and the ones defending it were aware of those and doing their best to defend that with very good counter arguments. And so that was great to see that. And I have to say, so impressive how in the intensity of the moment, both teams really staying in the game, staying focused. That was very impressive to see that. So it's really a wonderful honor to see such a great match. So congrats to the winner and, of course, both teams. Yeah.
Maybe just a little bit, what was impressive is the ability to move on to the next scope of question. For me, it was that. Because sometimes we end up debating back and forth about the same thing. It was great to see both teams seem to know exactly, oh, okay, I've put pressure enough on this point. I got to move on to the next one. And for this match, the next one is always another significant weakness of the other. So that was really good. I'm nerding out right now. Thank you.
So congratulations, the team. Also, like, it's a great fight because I learned about the curiosity. I think like US curiosity about the statistic, and I think like it takes like you want to be aware about your opponents, and I think to take those awareness in this intense. I mean, like, it's been like how many days? Yeah. So congrats. So yeah, great job.
Yeah, this is a very interesting match, especially neither of the groups actually experts in each different fields. Yeah. But you guys actually teach us how to criticize data, just looking at the data and how to pinpoint some of the weaknesses. So actually, I learned a lot myself. So thank you guys. Well done.
All right, that's the closing tournament for tonight. And big applause for all of us. Okay, once again, congratulations for team 28. Okay, so Rinjani, can yes, we will back to the Rinjani too. Thank you.